66 million years in the past, during a completely unremarkable spring dawn in the era we would eventually label the Cretaceous, a massive chunk of space debris roughly the size of a towering mountain was racing toward the planet Earth at an astonishing speed of 20 kilometers per second. This colossal object had been journeying through the freezing absolute silence of the cosmic void for millions upon millions of years. Its final trajectory had been sculpted by an almost infinite, chaotic sequence of gravitational pulls and pushes, the massive orbital drag of Jupiter, the slight bumps from passing cometary bodies, and the agonizingly slow rotation of its own axis. Yet, none of that ancient celestial history held any importance now. The only thing that mattered was that in precisely 4 hours, this 10-kilometer-wide sphere, composed of iron and carbonite, was destined to plunge into shallow, sunlit waters off the coast of what modern maps call Yucatan Peninsula. And that single impact would alter the fate of everything. The resulting collision unleashed a shockwave of energy equivalent to over 100 million nuclear warheads detonating simultaneously. It instantly vaporized billions of tons of ancient bedrock, raw sulfur, and ocean water, blasting an apocalyptic plume of debris high into the Earth's stratosphere. This dark cloud would wrap entirely around the globe in a matter of hours. Colossal firestorms raged across entire continents, consuming everything in their path. Monstrous tsunamis, measuring hundreds of meters in height, violently battered coastlines that were situated thousands of kilometers away from the impact crater. Following the fire and water came the endless dark, a suffocating, years-long twilight triggered as the sun was completely blotted out behind an impenetrable shroud of atmospheric dust and sulfur aerosols. This cosmic winter caused global temperatures to plummet by nearly 30 degrees Celsius. The planet's flora perished first, completely starved of the solar energy required to photosynthesize. Shortly after, the massive herbivores that relied entirely on that vegetation starved to death, followed inevitably by the apex carnivores that depended on the herbivores for sustenance. Within a mere blink of geological time, roughly 3/4 of every single living species on the planet had been wiped from existence. This mass die-off included every single dinosaur larger than a standard house cat. That is the established historical record. That is the undeniable truth fossilized forever in a razor-thin, iridium-rich layer of clay that acts as a dividing line between the Mesozoic and Cenozoic eras, resting just above the massive 200-kilometer scar buried deep beneath the limestone sediments of Mexico. But tonight, we are going to embark on a journey to visualize an entirely different timeline. We are going to ask the ultimate biological question. What would have transpired if that apocalyptic rock, that blazing mountain falling from the heavens, had actually missed? It was incredibly close to doing just that, or rather, it very easily could have. The exact flight path of any asteroid relies on a near-infinite string of variables stretching back across billions of years of cosmic history. A minuscule alteration in just one of those variables would have yielded a drastically different conclusion. Several modern researchers have mathematically modeled that if the Chicxulub impactor had crossed our orbit just a few minutes earlier or a few minutes later, the rotation of the Earth would have placed deep, abyssal ocean waters in its crosshairs rather than the shallow, sulfur-loaded coastal shelf. That would have meant significantly less vaporized bedrock, far less toxic sulfur injected into the stratosphere, and ultimately, a severe regional disaster instead of a globe-spanning mass extinction. The dinosaurs would have simply woken up the following dawn to a bruised and battered world, but a world that was by no means destroyed. And they would have carried right on doing exactly what they had mastered over the previous 165 million years, maintaining absolute dominion over every single terrestrial ecosystem on the face of the Earth. So, before you settle in for this journey, take just a moment to dim the lights in your room if you haven't already done so. Take a long, deep breath and allow the frantic noise of the modern world to simply fade into the background. Try to listen for the imaginary sound of the wind rustling through towering Cretaceous ferns. Envision the ambient noise of a prehistoric world bracing itself to endure and thrive, rather than preparing to burn and end. This is the grand narrative of 66 million years of evolution that was stolen from time, and we're going to walk through every single theoretical step of it together. The actual real-world discovery that an asteroid was responsible for wiping out the dinosaurs is an incredible narrative in its own right. It is a story worth summarizing because it perfectly highlights the very nature of how the scientific method operates. It shows how a wildly radical hypothesis, initially mocked and dismissed as pure science fiction fantasy, can slowly solidify into accepted, undeniable fact as the empirical evidence piles up. Back in the year 1980, a renowned physicist by the name of Luis Alvarez, working alongside his geologist son Walter, was carefully analyzing ancient rock formations near the town of Gubbio in Italy. While investigating the incredibly thin band of clay that signifies the boundary between Cretaceous and Paleogene periods, they discovered an anomaly. They found iridium, and an astonishing amount of it, roughly 30 times the standard expected baseline concentration. Iridium is an exceptionally rare element on the crust of the Earth. This is because the vast majority of the planet's iridium sank deep into molten iron core billions of years ago during the Earth's fiery formation. However, the element is incredibly abundant within asteroids and meteorites. The Alvarez team put forth the bold theory that a monstrous cosmic impact had taken place at the exact, precise moment the dinosaurs vanished from the fossil record. Furthermore, they made a bold prediction. Somewhere out there on the surface of the Earth, a colossal crater had to exist to prove their wild theory. The broader scientific establishment was highly skeptical. To say the least, a large number of geologists strongly favored more terrestrial, volcanic explanations. The massive Deccan traps located in modern-day India had been continuously erupting for millions of years during that exact same epoch, spewing out enough molten lava to blanket half of the Indian subcontinent in layers of solid basalt that were kilometers thick. Surely, the skeptics argued that environmental nightmare was more than enough to explain a global mass extinction. Yet, the Alvarez duo refused to back down. They continued to compile their data, and soon, other curious researchers joined the global scavenger hunt to find the missing crater. Years prior, in 1978, a sharp-eyed geophysicist named Glenn Penfield had spotted an odd anomaly while conducting surveying operations for an oil company in the Yucatan Peninsula. He noted a staggering, perfectly circular geological structure buried deep beneath the ocean sediments, completely invisible to naked eye but glaringly obvious on gravity and magnetic anomaly charts. He wasn't entirely certain what he was looking at, but he strongly suspected he had found a massive impact crater. It took another full decade for the academic community to finally connect the dots, for physical core samples retrieved from those Mexican oil drilling sites to be thoroughly tested and analyzed. Those samples were found to be riddled with shock quartz and tektites, rare, highly specific mineral formations that can only ever be forged under the unimaginable heat and pressure of a high-velocity asteroid impact. By the year 1990, the great debate was officially settled. The crater was a reality. It was the exact right age, and it possessed the exact right dimensions required to have triggered the apocalyptic extinction event. But here's the most crucial aspect regarding asteroid impacts, and it is the very foundation that allows our grand thought experiment to take place. These cosmic collisions are not predetermined destiny. They are not inevitable. They are the ultimate expression of pure, chaotic contingency, the random result of orbital mechanics and gravitational nudges playing out over timescales so incomprehensibly vast that the final outcome is essentially a roll of the cosmic dice. The Chicxulub projectile could have easily arrived a mere few minutes earlier and splashed harmlessly into the deep abyssal waters. It could have arrived a few hours later and detonated in the empty center of the Pacific Ocean. It could have missed our blue marble entirely, sailing quietly past our atmosphere and plunging deeper into the cold outer solar system, never to cross paths with Earth again. In every single one of those alternate scenarios, the great dinosaurs would have lived. Not because they were somehow magically destined to survive, but simply because a highly specific, incredibly unlucky random event that slaughtered them would have never taken place. Our alternate history kicks off in that exact divergent second. The asteroid screams violently through the Earth's upper atmosphere, painting a blinding, white-hot scar across the sky that can be seen from 1,000 kilometers away. It smashes into the deep Pacific Ocean, a full 2,000 kilometers away from a nearest landmass. The impact generates terrifying tsunamis that absolutely devastate the coastal regions stretching across the Americas and Eastern Asia. Millions upon millions of coastal creatures perish in the deluge. Local ecosystems are severely disrupted and fractured for decades to come. However, the deadly sulfur remains safely trapped beneath the crushing weight of the ocean. The atmospheric dust and ash settle back to ground in a matter of months, rather than hovering for years. The sun continues to shine brightly. The global plant life continues to grow and photosynthesize. And the dinosaurs, the towering Tyrannosaurs, the grazing Triceratops, the bellowing Hadrosaurs, the heavily armored Ankylosaurs, and the tiny, feathered Maniraptorans darting through the ancient underbrush, all continue their ancient, uninterrupted reign exactly as if nothing world-ending had occurred. Because, as far as their global dynasty is concerned, nothing truly world-ending has happened. They had endured far worse challenges in their deep history. They had successfully navigated the suffocating volcanic winters brought on by the Deccan Trap eruptions. They had survived the gradual, creeping, cooling trends of the late Cretaceous period. They had adapted to the slowly shifting continents and the violently fluctuating sea levels that had been continuously repainting their world for millions of years. They remained the absolute most successful group of large, terrestrial animals that the planet had ever managed to engineer, and they displayed zero biological signs of slowing down or declining. Their genetic diversity was arguably at its absolute peak. Their body sizes spanned an incredible spectrum, from tiny, chicken-sized insect eaters to lumbering, 40-ton mountains of herbivorous flesh. They successfully occupied nearly every conceivable ecological niche on the map, thriving everywhere from freezing Arctic forests to sweltering tropical swamplands. They had been perfecting the survival game for 165 million years, and there was absolutely no biological barrier or genetic reason why they could not simply continue for another 165 million more. The Earth belonged unequivocally to the dinosaurs. And now, for the first time in the history of our planet, we are going to explore exactly what they would have done with that unlimited potential. To properly understand what this alternate future might have looked like, we must first deeply understand what the reality of the past actually was. We must temporarily step back from the theoretical alternative history we are currently constructing and take a profound, clear-eyed look at the actual physical planet that these magnificent creatures were poised to continue inheriting. We must completely discard the heavily simplified, cartoonish depictions so frequently found scattered across the pages of children's literature. We must simultaneously erase the bleak, ash-choked, cinematic monster movie landscapes that so routinely dominate the popular cultural imagination. Instead, we must focus our lens on the genuine, breathtaking reality of the late Cretaceous Earth, embracing it in all of its staggering complexity, vibrant ecosystems, and utter environmental strangeness. You must entirely forget the barren, smoking, volcanic hellscapes that are so frequently utilized to set the prehistoric scene in popular media. The actual living world of 66 million years ago was a planet defined by extraordinary biological abundance, characterized by a global climate that was significantly warmer, infinitely more humid, and drastically wetter than anything we human beings have ever experienced in our modern era. There were absolutely no permanent, freezing ice caps located at either of the planet's northern or southern poles. The global sea levels rested at an astonishing height, perhaps measuring a full 170 meters higher than the depths of our current modern oceans. This massive swelling volume of water completely drowned ancient coastal plains and violently fractured massive continental landmasses, creating vast, sunlit, shallow inland seas. The landmass we now recognize as North America was not a single, unified continent, but rather two distinct landmasses. They were physically divided by a warm, vibrant marine waterway known to geologists as the Western Interior Seaway, a sprawling channel that stretched uninterrupted from the prehistoric Gulf of Mexico all the way up to the freezing latitudes of the Arctic Ocean. India, during this epoch, was an immense, detached island, drifting steadily northward on an inevitable, incredibly slow collision course with the underbelly of the Asian continent. Australia still clung tightly to the frozen bedrock of Antarctica, and yet both of these massive southern landmasses were entirely green, blanketed from coast to coast in lush, temperate forests. The very air that these animals breathed was fundamentally different. Atmospheric carbon dioxide levels were astonishingly high, perhaps hovering at 4 times the concentration they rest at today. Ambient oxygen levels were also slightly elevated compared to our modern baseline. This intense, unrelenting greenhouse effect functioned as a planetary thermal blanket, keeping the entire globe comfortably warm from pole to pole. Massive crocodilians swam and hunted freely in waters situated well above the Arctic Circle. Dense, sprawling forests grew thick and wild in the exact same geographic locations, where the crushing weight of the Antarctic ice sheets now relentlessly grind against the continental bedrock. And everywhere you looked, thriving perfectly in almost every single terrestrial ecological niche you could possibly imagine, there were the dinosaurs. The absolute best window we currently possess into this vanished, vibrant world is a spectacular geological location known as the Hell Creek Formation. This is a massive, sprawling layer of sedimentary rock stretching across the Badlands of Montana, the Dakotas, and Wyoming that miraculously preserves the final 3 million years of Cretaceous period in absolutely exquisite, unparalleled detail. When dedicated paleontologists excavate the earth there, they do not merely uncover isolated, fragmented bones. They unearth an entire, interconnected community of prehistoric life permanently frozen in stone. It is a complete, functioning ecosystem that modern science can meticulously reconstruct with a remarkable degree of precision. The undisputed, reigning monarch of this specific ancient world was Tyrannosaurus rex, and it is highly worth spending a prolonged moment to truly, accurately visualize this animal exactly as it was in life. You must not picture the lumbering, slow-moving, tail-dragging reptilian caricature of early 20th century museum reconstructions, but rather something far more biomechanically terrifying, and yet far more physically beautiful. Spanning a full 12 meters in length from the tip of its snout to the end of its muscular tail, it was roughly 9,000 kilograms of dense muscle and reinforced bone. This incredible bulk was entirely supported on legs that were structurally built incredibly similar to those of an avian sprinter, evolutionarily designed for terrifying bursts of explosive acceleration rather than long-distance, sustained running. It possessed a skull so unfathomably large that it could easily swallow a full-grown human being whole, lined with dozens of terrifying teeth roughly the size and shape of bananas. Every single one of these teeth was deeply serrated along the edges, exactly like a high-end steak knife. Each individual tooth was fully capable of punching directly through solid bone with the exact same ease that a human being might experience biting into a crisp apple. But the single most remarkable and lethal feature of this predator was its eyes. Rex possessed forward-facing eyes, set deeply into a skull that was distinctly narrow at the front. This unique cranial anatomy granted the massive predator overlapping, binocular vision. It possessed true depth perception, a highly predatory trait that was surprisingly rare among large dinosaurs. A fascinating scientific study conducted by vision researcher Kent Stevens mathematically calculated that the visual acuity of Tyrannosaurus rex far exceeded that of modern hunting hawks. The data suggested that it could easily spot a prey animal moving from over 6 kilometers away, and that its neurological ability to accurately judge physical distance was among the absolute best of any terrestrial animal that has ever walked the face of the earth. This was undeniably not a slow, opportunistic scavenger, simply waiting around for a herbivore to succumb to old age or disease. This was the ultimate apex predator, fully equipped with the biological sensory equipment of an elite, precision hunter. However, Rex was the absolute extreme exception among Cretaceous predators, not the standard rule. The Hell Creek ecosystem successfully supported a whole diverse range of specialized carnivores, each perfectly filling out different ecological niches. There were smaller, more agile tyrannosaurids that may very well have hunted their prey in highly coordinated social groups. There are the terrifying dromaeosaurids, equipped with their world-famous razor-sharp sickle claws. And there were the deeply fascinating troodontids. These were strange, remarkably large-eyed nocturnal hunters whose physical brains, when measured relative to their overall body size, were significantly larger than those found in any other known dinosaur group. We will be returning to the evolutionary potential of the troodontids later in this journey, because their existence matters enormously to the trajectory of our story. For the time being, simply make a mental note that they were there, small, incredibly smart, and quietly watching the ancient world unfold around them with eyes that comprehended far more than most of their reptilian peers. The plant-eating herbivores of this era were even more staggeringly diverse, and among this varied group, one specific animal dominated the landscape so completely and overwhelmingly that it is genuinely hard to overstate its ecological importance. Triceratops. Famed paleontologist Robert Bakker once mathematically estimated that the physical fossilized bones of Triceratops make up an astonishing 5/6 of all large dinosaur fossils recovered from late Cretaceous North America. And if that staggering percentage is even remotely close to being accurate, we need to fundamentally and radically reimagine how we view the Cretaceous landscape. Think of the Great American Plains long before European contact occurred. Think of a time when massive bison herds stretched endlessly from one horizon to the next, when the very ground beneath your feet trembled under the synchronized weight of millions of hooves, when a traveler could easily journey for days on end without seeing anything but oceans of grass and grazing animals. Now, take that image and replace every single one of those mammalian bison with a 3-horned, 9-meter-long biological tank. Picture an animal weighing up to 9,000 kilograms, possessing a massive, solid-bone skull that made up a full 1/3 of its entire physical body length. It wielded forward-facing horns that could effortlessly gore a charging Tyrannosaur, complemented by a massive frill of solid bone perfectly protecting its vulnerable neck. That was Triceratops. It was the absolute Cretaceous equivalent of the North American bison, except it was heavily armored from head to tail like a medieval knight preparing for a siege. Living right alongside the massive herds of Triceratops were the highly successful hadrosaurids. These were the famous duck-billed dinosaurs, equipped with their truly remarkable evolutionary marvels known as dental batteries. These batteries consisted of hundreds upon hundreds of tightly interlocking teeth, vertically stacked in dense columns, constantly and endlessly being replaced from the jawline below. This incredible biological machinery rendered them fully capable of aggressively grinding down the toughest, most fibrous prehistoric vegetation in a highly efficient manner that absolutely no other dinosaur group had ever successfully achieved. There was also Ankylosaurus, the undisputed armored fortress of the Cretaceous plains. Its entire upper body was heavily covered in interlocking, bony plates known scientifically as osteoderms. Its muscular tail ended abruptly in a massive, heavy club of fused bone that could easily shatter a rushing predator's leg into 1,000 pieces with a single, well-aimed swing. There was a bizarre Pachycephalosaurus, sporting its famous, incredibly thick dome of solid bone resting atop its skull. This structure was quite possibly utilized for intense head-butting contests fighting over territory or mates, much like modern bighorn sheep do today, although dedicated paleontologists still fiercely argue over the exact biomechanics of this behavior. And scurrying below all of these giants were dozens upon dozens of far smaller species, each perfectly filling its own tiny, specialized niche in the grand ecosystem. There were small ornithopods quietly browsing in the dense forest undergrowth. There were oviraptorosaurs carefully tending to their elaborate ground nests. And there were the tiny, insignificant mammals, frantically scurrying through the decaying leaf litter under the safety of the night sky. Soaring high above this bustling, terrestrial world flew the magnificent pterosaurs. And we need to pause our narrative right here for just a moment to clarify an important scientific distinction, because the pterosaurs are technically not dinosaurs. They belong to a completely separate evolutionary lineage entirely. They are closely related, but distinctly separate, functioning more like evolutionary cousins rather than direct siblings to the dinosaurs. The absolute largest and most terrifying of these flying reptiles was Quetzalcoatlus, wonderfully named after the famous, feathered serpent god of ancient Aztec mythology. And when I tell you that this creature possessed a maximum wingspan that reached an astonishing 11 meters across, I need you to pause and actually vividly picture that scale in your mind's eye. It was wider across than a modern small airplane. It was physically larger than any other flying animal that has ever existed in the known history of the Earth, either before its time or in the millions of years since. Standing firmly on the ground on all 4 of its limbs, this towering creature would have been able to look a fully grown, modern African giraffe directly in the eye. Yet its internal bone structure was highly pneumatized and hollow, deeply honeycombed with complex air pockets. Its skeleton was so remarkably lightweight that this towering creature, roughly the physical size of a small private aircraft, probably weighed only about 250 kilograms in total, meaning it weighed significantly less than many adult human beings. It likely hunted very much like a gigantic, terrifying stork, stalking silently across the open floodplains on folded wings, suddenly snatching up small, unsuspecting dinosaurs, tiny mammals, and slippery fish using a massive, spear-like beak that was roughly the entire length of an adult human arm. And what exactly about the mammals during this golden age? They were certainly there. They had absolutely been there all along, quietly evolving right alongside the magnificent dinosaurs from the very beginning of the Mesozoic era, successfully sharing the exact same planet for well over 150 million years. But they were incredibly small. The absolute largest known Cretaceous mammal that has ever been discovered was perhaps roughly the size of a modern badger. The vast majority of them were no bigger than modern mice or rats, creeping silently through the dense underbrush, expertly climbing the trunks of massive trees under the cover of night, and hunting tiny insects and seeds, while living entirely within the deep ecological shadows cast by the reptilian giants. They were by no means evolutionary failures. They were, in fact, incredibly successful at exactly what they did. But what they did best was simply stay completely out of the way. The only ecological niches they successfully occupied were the tiny, leftover niches that the massive dinosaurs simply didn't want or couldn't fit into. The pitch-black nocturnal niche, the deep underground burrowing niche, the tiny, scurrying insectivore niche. Absolutely everything else under the sun belonged unequivocally to the ruling reptiles. This was a vibrant, thrumming world on the fateful morning that the asteroid miraculously missed. A world defined by endless warmth and staggering biological abundance. A world driven by continental drift, vast shallow seas, highly evolved theropod hunters, endless Ceratopsian herds, and massive pterosaurs soaring effortlessly on the thermal updraft high above it all. It was a perfectly balanced world that had been meticulously refining itself for well over 165 million years. A world that showed absolutely zero signs of evolutionary decline. A world that was, if anything, operating at the absolute, undisputed peak of its genetic diversity and ecological success. The dinosaurs were absolutely not waiting around to be magically replaced. They were not tragic evolutionary dead ends stumbling blindly toward an inevitable cosmic extinction. They were the most phenomenally successful group of large terrestrial land animals that the planet Earth had ever managed to produce. And they possessed every biological reason to fully expect that their golden reign would simply continue on indefinitely. It almost didn't, of course. In our actual documented timeline, the burning rock from deep space abruptly ended absolutely everything. But in the theoretical timeline we are deeply exploring tonight, the rock splashed completely harmlessly into the deep waters of the Pacific Ocean, and the great dinosaurs simply woke up the very next morning to carry right on continuing what they had already been doing for 165 million years. The monumental question we must now ask is, what exactly would they have done with another 66 million years of uninterrupted evolution? What spectacular forms would they have eventually become? To accurately answer that question, we first need to deeply understand something that the dinosaurs themselves could not have possibly known or anticipated. The planet was about to radically change. Not suddenly, not catastrophically from a singular cosmic impact, but slowly, steadily, and absolutely inexorably over the course of tens of millions of years. The incredibly warm, deeply stable greenhouse climate of the Mesozoic era was gradually coming to an end. A long, drawn-out planetary cooling phase was steadily approaching, driven entirely by the unimaginably slow drift of the tectonic plates, by the violent, grinding rise of new mountain ranges, and by the fundamental altering of deep ocean circulation currents that would eventually act to permanently lock the continent of Antarctica under kilometers of solid ice. Entirely new, revolutionary forms of plant life were slowly evolving, most notably grasses, which would eventually spread like a wildfire across the globe and permanently transform every single ecosystem they physically touched. The dinosaurs were about to face a gauntlet of environmental challenges that they had never once encountered in 165 million years of constant evolution. They were challenges that would ultimately test their biological adaptability in ways the sudden violence of an asteroid impact never could. But first, let's take a moment to closely look at exactly why the dinosaurs were so overwhelmingly dominant in the first place, and why the mammals, our own direct ancestors, seemingly couldn't manage to break out of their tiny, restrictive ecological shadows. The true scientific answer is not what you might initially think. There's a very specific, comforting story that gets repeatedly told in countless nature documentaries and high school science textbooks. It is a highly comfortable, human-centric narrative that neatly attempts to explain exactly why the biological world looks the way it does today. It generally goes something like this. The dinosaurs were lumbering, sluggish, cold-blooded evolutionary failures. They were tragic biological dead ends that only managed to dominate the planet because absolutely nothing better or more advanced had managed to come along yet. They were depicted as big, remarkably dumb creatures, absolute slaves to their primitive instincts, and completely unable to adapt to rapidly changing environmental conditions. Therefore, when a fiery asteroid finally struck the Earth, it simply functioned to violently clear the biological stage for the true, destined inheritors of the Earth, the mammals. We were warm-blooded, highly intelligent, and we had simply been waiting patiently in the evolutionary wings for our grand moment to finally shine. The mass extinction event is almost portrayed as a necessary cosmic mercy, a required planetary reset that finally allowed evolution to get things right. This comforting narrative is almost entirely, fundamentally wrong, and deeply understanding exactly why it is wrong is absolutely essential to understanding what would have transpired if the dinosaurs had survived the impact. The dinosaurs were absolutely not biological failures, patiently waiting to be replaced by a superior design. They were an evolutionary triumph of truly staggering, incomprehensible proportions, arguably the absolute most successful group of large land animals the planet has ever seen. They ruthlessly dominated the terrestrial ecosystems for well over 165 million years. I want you to try to genuinely wrap your mind around the sheer scale of that number for a moment. Anatomically modern humans, our exact species, have existed for perhaps roughly 300,000 years. The entire broader genus Homo, which includes all of our various extinct, upright walking relatives, goes back maybe 2.5 million years at most. The great dinosaurs maintained their iron grip on the planet for 66 times longer than that entire span. They successfully evolved into many thousands of distinct species. They masterfully filled every conceivable ecological niche on the board, ranging from tiny, darting insectivores to towering 40-ton forest browsers. They successfully spread their populations across every single continent on the map, adapting flawlessly to every climate ranging from sweltering tropical rainforests to freezing, dark polar winters. And crucially, they showed absolutely zero signs of genetic decline or evolutionary fatigue in the final millions of years right before the asteroid struck. If anything at all, their overall biodiversity was actively increasing. The late Cretaceous period was absolutely not a period of dinosaurian senescence or decay. It was their absolute golden age. So, why exactly did the mammals remain so incredibly small for so long? Why, after a staggering 150 million years of direct side-by-side coexistence with the dinosaurs, hadn't the mammalian family tree managed to produce a single creature physically larger than a common badger? The traditional, accepted answer is wonderfully simple. The massive dinosaurs were actively suppressing them. The large, profitable ecological niches were entirely occupied by giant dinosaurs, and the tiny mammals simply could not physically compete for the resources. They were violently forced out into the extreme margins, pushed into the dark of night, driven into deep underground burrows, and forced high up into the treetops where the massive reptilian giants simply couldn't follow them. The theory stated that if you simply remove the dinosaurs from the equation, the mammals would instantly and explosively radiate into all of that newly vacant ecological space. While this explanation certainly possesses a certain intuitive, logical appeal, recent, highly advanced paleontological research heavily suggests that it is vastly incomplete at best and quite possibly entirely backward. A major, groundbreaking 2021 scientific study, conducted jointly by Oxford and Birmingham universities, meticulously analyzed the complex evolutionary constraints placed on different mammal groups both directly before and immediately after the KPG extinction event. They utilized highly sophisticated statistical methods and computational modeling to precisely identify where each individual mammalian lineage was actively hitting its ecological limits. What the researchers ultimately found was truly surprising. The direct, ancient ancestors of modern placental and marsupial mammals, The very specific groups that would eventually go on to produce everything from massive blue whales to towering elephants to modern human beings weren't actually primarily competing with the dinosaurs at all. They were actively being outcompeted by other, completely different groups of mammals. The Mesozoic era wasn't simply home to the tiny, shivering, shrew-like creatures we usually tend to imagine when we think of early mammalian life. It actually hosted a truly remarkable, staggering diversity of bizarre mammalian lineages, the vast majority of which are now completely and utterly extinct. There were the multituberculates, the Gondwanatherians, the Eutriconodonts, and the Dryolestids. These bizarre, ancient animals had already firmly and aggressively claimed the vast majority of the highly profitable small to medium body size ecological niches long before our ancestors could reach them. Some of these strange mammals were fully adapted gliders, soaring between trees. Some were highly efficient aquatic swimmers. Some were dedicated, deep earth burrowers. Some possessed highly specialized teeth perfectly evolved for cracking open incredibly hard foods, while others possessed teeth designed for cleanly slicing through raw meat, and still others possessed flat teeth for endlessly grinding down tough plants. The direct ancestors of our modern mammals weren't being aggressively held back by distant, towering dinosaurian giants stomping around above them. They were actually being brutally outcompeted by their very own much closer relatives, by other, highly specialized mammals that were simply vastly better adapted to surviving the specific environmental conditions of the Mesozoic era. Now, take a moment to deeply think about what this biological reality actually means for the trajectory of our alternative timeline. When the blazing asteroid didn't strike the Earth, the dinosaurs obviously continue to live. Yes, absolutely. But so did all of these other, highly specialized mammal groups. The deeply successful multituberculates, which, remarkably, in our own actual timeline somehow managed to survive the apocalyptic extinction event and stubbornly persisted for another 30 million years before finally dying out, would have simply kept aggressively competing for resources with the tiny ancestors of modern rodents. The strange Gondwanatherians would have stubbornly kept occupying the exact same vital ecological niches that our modern marsupials might otherwise have eventually evolved to fill in the southern hemisphere. The biological playing field simply wouldn't have been cleared for our ancestors to rise. The specific, marginalized mammals that eventually managed to give rise to modern elephants, complex primates, and eventually humans would have simply remained permanently trapped inside the exact same brutal, highly competitive evolutionary squeeze they had already been hopelessly experiencing for 150 million years. They would have remained endlessly pressed from high above by the dominance of the dinosaurs, and endlessly pressed from the sides by the dominance of their own, highly successful mammalian kind. But let us dive even deeper into biology. Let us ask exactly why the dinosaurs were so incredibly, unbeatably good at being physically large in first place. Because the scientific answer to this question reveals something truly fundamental about the biological constraints that our alternative history would have been forced to operate under. Dinosaurs possessed a highly advanced respiratory system that mammals simply cannot ever hope to mathematically match. Exactly like modern birds, which are, after all, simply surviving, highly derived living dinosaurs, they breathed utilizing an incredibly efficient system of unidirectional airflow. The air passed entirely through a set of rigid, immobile lungs that were heavily supplemented by an expansive network of balloon-like air sacs that extended deeply throughout their entire physical bodies, even reaching directly into the hollow cavities of their very bones. When a typical mammal takes a breath, ambient air flows down into the soft lungs and then is forced to travel right back out the exact same way it came in. This constantly mixes fresh, highly oxygen-rich air with stale, carbon dioxide-rich air. It is a fundamentally, biologically inefficient system. When a large dinosaur took a breath, the ambient air flowed in one continuous, unstoppable direction only. It passed steadily over the critical gas exchange surfaces of the lungs completely continuously, successfully extracting far more vital oxygen per single breath than a mammal ever could. This exact biological mechanism is the very reason why modern birds can effortlessly fly straight over the freezing peak of Mount Everest, while elite mammalian climbers are left desperately gasping for oxygen at base camp. This is exactly why the magnificent sauropods could easily grow to achieve weights of 50 tons, while the absolute largest land mammals in Earth's history have almost never managed to exceed a mere 20 tons. The dinosaurs weren't simply passively occupying the large-body ecological niches by chance. They were vastly, physiologically superior at simply being large. They also possess a skeletal structure of hollow bones, heavily pneumatized with complex air pockets that directly connected to their advanced respiratory system. This evolutionary marvel made their massive skeletons significantly lighter relative to their physical strength than absolutely any mammal could ever hope to biologically achieve. They possessed dramatically faster physical growth rates, easily reaching their towering adult sizes in a matter of mere years, rather than the long, vulnerable decades required by similarly sized large mammals. They also laid external eggs, which critically meant that the females did not have to endure the immense, crippling physical burden of carrying their massively developing young internally inside their bodies. A heavily pregnant, 50-ton sauropod carrying a live infant would have been an absolute biomechanical impossibility. But an egg-laying sauropod could easily, efficiently produce dozens of independent offspring per single year. Every single aspect of their internal biology was ruthlessly, perfectly optimized for the massive ecological roles they have been effortlessly filling for 165 million years. A tiny mammal attempting to slowly evolve into a massive, large-bodied herbivore in this intensely competitive world would have faced towering competitors who could literally breathe far more efficiently, grow to adulthood significantly faster, reproduce in far greater numbers, and carry vastly less overall skeletal weight per unit of structural bone strength. It is not that mammals were somehow biologically inferior as an entire group. They were simply attempting to violently compete in an evolutionary game where the fundamental biological rules massively favored an entirely different reptilian body plan. If you take mammals and place them alone in the vast, empty ecological vacuum left behind by the KPG extinction event, give them a full 66 million years entirely without dinosaurian competition, and they will eventually successfully produce towering elephants, massive ocean-dwelling whales, and gigantic ground sloths. But if you keep the dominant dinosaurs around, the mammals will simply remain exactly what they had always been: small, hypersecretive, deeply nocturnal, and entirely ecologically marginal. This is the exact, unyielding world that our alternative timeline naturally inherits. It is not a fragile world where dinosaurs are somehow failing, tragic relics desperately clinging to existence. It is a vibrant, terrifying world where they're the absolute, undisputed biological masters of every single terrestrial ecosystem on the map. It is a world where their sheer physiological and biological advantages make them essentially totally unassailable in the massive ecological niches they comfortably occupy. And it is a world where the tiny mammals are permanently, hopelessly locked into their traditional, shadowy roles by intense, unending competitive pressure coming from multiple different evolutionary directions. The dinosaurs absolutely did not win their global throne by sheer accident or by default. They violently won it by being extraordinarily, unbeatably good at exactly what they did. And absolutely nothing about the asteroid's miraculous near miss would have changed that unyielding fact. But this is exactly where the narrative takes a truly fascinating turn. The undisputed, global dominance of the dinosaurs was fundamentally built upon the bedrock of an incredibly stable, exceptionally warm planetary climate that had stubbornly persisted throughout the entirety of the Mesozoic era. For a staggering 165 million years, the Earth had operated as a massive, unbroken greenhouse world. It was comfortably warm from pole to pole, thick with humidity, heavily forested, and characterized by remarkably little seasonal variation. The dinosaurs had originally evolved within this specific, highly favorable biological paradigm, and were exquisitely, perfectly adapted to its conditions. They had absolutely never faced the bitter, freezing reality of an ice age. They had never laid eyes upon an open, sprawling grassland. They had absolutely never experienced the kind of violent, dramatic climate swings that would eventually come to deeply characterize the approaching Cenozoic era. The entire planet was on the verge of changing in profound ways the dinosaurs had never once encountered. The massive continental plates were slowly drifting into entirely new geological configurations, ripping open vital ocean gateways that would fundamentally alter deep water circulation patterns around the entire globe. Antarctica was steadily, inexorably ripping itself away from the southern tip of South America. And within a mere few million years, a freezing, circular ocean current will begin to ruthlessly isolate that entire southern landmass, eventually seeding it with miles of solid, unforgiving ice. The mighty Himalayas were preparing to violently thrust upward into the atmosphere as the Indian subcontinent crashed headlong into the belly of Asia. The chemical weathering of those vast, newly exposed rock faces would soon begin forcefully drawing massive amounts of carbon dioxide straight out of the atmosphere, initiating a slow, planetary cooling effect. Vast, open grasslands were preparing to spread like a green wildfire across multiple continents, actively creating entirely new, unprecedented ecosystems complete with entirely new, brutal selective pressures. The dinosaurs had already overwhelmingly proven themselves to be the undisputed biological masters of the Mesozoic world. The central, burning question that our alternative history must now accurately answer is whether or not these magnificent creatures could have successfully mastered the Cenozoic world as well, a world that was destined to become significantly colder, vastly drier, infinitely more seasonal, and far more environmentally variable than absolutely anything they had successfully experienced in their long, triumphant evolutionary history. It was a shifting world that would have ruthlessly tested their biological adaptability in ways the sudden violence of a rogue asteroid never could. It was an environment that would have actively demanded rapid, genetic innovations that their specific lineage had never before been forced to biologically produce. They were granted exactly 66 million years of uninterrupted time to find out. Let us closely examine exactly what they might have done with that gift. A full 10 million years have quietly slipped by since the blazing asteroid miraculously missed the Earth. And if you could somehow manipulate the fabric of time and physically travel back to the specific epoch, you might not actually notice anything distinctly different at first glance. The great continental plates haven't physically moved all that much. The mechanics of continental drift operate on agonizingly slow time scales measured in mere centimeters per year. In a span of 10 million years simply isn't enough time to rearrange the global geography in any truly dramatic or unrecognizable way. The global climate is still incredibly warm, still suffocatingly humid, and still lushly tropical, even at incredibly high northern and southern latitudes. The dense, sprawling forests still stretch uninterrupted from pole to pole, vibrant, aggressively green, and constantly dripping with heavy moisture. It looks, at first passing glance, exactly like the familiar Cretaceous world we just left behind. But biological evolution never, ever stands still. Even when the physical world appears entirely, completely static on the surface, 10 million years is an absolutely enormous, almost unfathomable span of time. It is a period significantly longer than the entire biological existence of the human genus Homo. It is a span of time vastly longer than the era separating the very first primitive chip stone tools from a highly advanced, glowing smartphone resting in your pocket today. Biological species simply do not remain static or frozen over such immense periods. They naturally drift, they forcefully adapt, they highly specialize, and they continually diverge. The dinosaurs occupying the Earth 10 million years post-asteroid would absolutely not be genetically or physically identical to the dinosaurs of the late Cretaceous, even if their surrounding environment remained superficially, structurally the same. The single most significant, revolutionary change taking place during this specific period wouldn't have actually been found within the dinosaurs themselves, but rather within the very plants they biologically depended upon for their survival. The incredible flowering plants, known scientifically as angiosperms, had been slowly, steadily spreading their roots throughout the entire Cretaceous period. They had been rapidly diversifying and fiercely competing for sunlight with the much older, more primitive conifers and ferns that had thoroughly dominated the ancient Mesozoic forests. Without the sudden, catastrophic environmental disruption of the global extinction event, this silent botanical conquest would have continued completely unabated. The angiosperms possess inherent genetic advantages that made their eventual global botanical dominance almost an absolute inevitability. They could biologically reproduce significantly faster, they could evolve and mutate much more quickly, and they could form highly intimate, complex symbiotic relationships with local pollinators and animal seed dispersers. By the time we reach 10 million years after our initial point of divergence, the flowering plants would have successfully conquered the vast majority of the world's dense forests, and a massive percentage of them would have actively been bearing nutritious fruit. Fruit is undeniably one of biological evolution's absolute greatest, most cunning innovations. It is essentially a highly calculated nutritional bribe directly offered by stationary plants to mobile animals. The evolutionary bargain is simple. Consume this incredibly sweet, highly nutritious, energy-dense flesh, and then unknowingly carry my protected seeds somewhere far away inside your digestive tract. Deposit them safely into a fresh patch of soil, perfectly packaged within a pile of nitrogen-rich fertilizer. Give my genetic offspring a massive, protected head start in the brutal game of life. It is a biological strategy that works so spectacularly, incredibly well, which is exactly why it managed to evolve completely independently across so many different, entirely unrelated plant lineages. In our actual documented historical timeline, the sudden massive explosion of fruit-bearing plants in the early Cenozoic era directly helped to rapidly drive the evolution of fruit-eating mammals. It fueled the rise of the early primates, the very lineage that would eventually, millions of years later, give rise to human beings. In our theoretical alternative timeline, that exact same massive ecological opportunity would have been wide open and available. However, the specific animals that were absolutely best physically positioned to immediately exploit this new, sugary bounty wouldn't have been the tiny, ground-dwelling mammals. They would have undeniably been the dinosaurs. The small maniraptor theropods, the highly successful lineage that directly includes the sickle-clawed dromaeosaurids, the large-brained troodontids, the peculiar oviraptorosaurs, and the direct, feathered ancestors of all modern birds, were already prominently showcasing physical adaptations that would have served them spectacularly well in these new, fruit-rich, towering forests. They already possessed highly dexterous, grasping hands that were perfectly capable of manipulating small objects and firmly gripping high branches. Many of them already possessed forward-facing eyes that provided them with excellent, overlapping binocular vision, which is absolutely vital for accurately judging complex physical distances when reaching for hanging food or dangerously leaping between swaying tree branches. They were physically small enough to easily climb, and incredibly light enough to safely venture far out onto the thinnest, most delicate branches that would have instantly snapped under the massive weight of any larger dinosaur. And some of them, the bizarre oviraptors in particular, had already successfully evolved strong, completely toothless beaks that might have been spectacularly well suited for crushing and processing tough-skinned fruit and hard seeds. I want you to vividly picture a highly derived descendant of this specific lineage, existing 10 million years deep into our alternative timeline. It is relatively small, perhaps roughly the physical size and weight of a modern South American howler monkey. Its entire body is densely covered in a vibrant, complex coat of highly colorful feathers that perfectly serve a dual biological purpose for both thermal insulation and elaborate visual display. Its front hands still retain classic, three-clawed fingers of its ancient, ground-dwelling theropod ancestors, but they have become vastly more dexterous, much longer, and far more capable of incredibly fine, delicate physical manipulation. Its strong beak has evolved a very slight, sharp hook right at the very tip, incredibly useful for effortlessly tearing open the tough, fibrous skins of tropical fruits. It lives its entire existence high up in the dense, swaying canopy of the flowering forests, effortlessly and acrobatically leaping from one branch to the next, peacefully feeding on the endless, sugary bounty that the spreading angiosperms so generously provide. This creature is, of course, purely an act of scientific speculation. We simply cannot ever know the exact, precise physical forms that evolution would have generated in an alternative universe. But it is speculation deeply and firmly grounded in highly realistic evolutionary trends. It is based upon actual, documented adaptations that were already fully present in late Cretaceous maniraptorans, stepping into massive ecological opportunities that would have genuinely, unquestionably existed. The newly established, towering flowering forests would have massively, disproportionately rewarded absolutely any biological lineage that was physically capable of exploiting them. And the small, highly agile, feathered maniraptor theropods were simply vastly better positioned to do exactly that than absolutely any primitive mammal alive during that specific period. But the incredible evolutionary changes wouldn't have been strictly confined to the high canopy. Down below, On the shadowed forest floor, the truly massive, great herbivorous dynasties of the late Cretaceous would have been continuously, relentlessly driving their own parallel evolution, rapidly responding to the rapidly changing biological composition of the new plant communities they entirely depended upon for survival. The magnificent hadrosaurs, the great duck-billed dinosaurs, had already successfully evolved the absolute most highly sophisticated, advanced plant processing equipment of any dinosaur lineage in history. Their complex dental batteries, containing many hundreds of tightly interlocking teeth that were constantly, endlessly being replaced from the jaw below, were fully capable of aggressively grinding down incredibly tough, fibrous vegetation with an unparalleled efficiency that absolutely no other dinosaur could ever hope to match. As the new flowering plants aggressively spread across the globe, bringing with them entirely different physical textures and wildly varying nutritional profiles, the massive hadrosaurs would have biologically adapted right alongside them. Some specific lineages might become incredibly, highly specialized, focusing all of their evolutionary energy on perfectly digesting particular, toxic types of plants in highly specific, localized habitats. Other closely related lineages might have gone the opposite route, becoming highly adaptable generalists, fully capable of surviving and actively thriving on absolutely whatever tough vegetation happened to be currently available. The single most vital key point to understand is that they absolutely wouldn't have stood still. Biological evolution never, ever does. The heavily armored Ceratopsians, too, would have ruthlessly continued their massive global radiation. Back in the late Cretaceous, they had already successfully diversified into many dozens of distinct, highly unique species stretching across both North America and the Asian continent. They varied wildly in physical size, ranging from tiny, dog-sized runners to massive, lumbering, elephant-sized tanks, constantly sporting an absolutely astonishing, almost comical variety of elaborate horn and bone frill configurations. Without the sudden violence of the extinction event to wipe the slate clean, this incredible physical diversity would have simply continued to rapidly expand and mutate. Perhaps some specific lineages of Ceratopsians would have become even larger, pushing the absolute biological limits of bone and muscle, naturally filling out the massive ecological niches that in our actual timeline would eventually be occupied by towering elephants and heavily armored rhinoceroses. Perhaps entirely other lineages would have become drastically smaller, vastly more nimble, and perfectly adapted to navigating incredibly dense, tangled habitats or exploiting entirely different, localized food sources. And the magnificent sauropods, those towering, impossibly long-necked giants that had so thoroughly defined the distant Jurassic period but seemed to be very slowly declining in overall diversity by the end of the late Cretaceous, would have absolutely persisted as well. They were the ultimate, towering biological specialists. They were perfectly engineered to reach massive, high-altitude food sources that absolutely no other terrestrial herbivore on the planet could even dream of accessing. And as long as those incredibly tall, ancient forests continued to exist on the globe, the sauropods would have maintained a vital, irreplaceable role to play in the ecosystem. In our actual historical timeline, the fiery extinction event violently removed them from the board before we could ever witness exactly how they might have gracefully adapted to a rapidly changing, cooling world. In our theoretical alternative timeline, they would have finally been granted the millions of years necessary to definitively prove their ultimate evolutionary staying power. The physical world of 10 million years post-Asteroid would have been largely, structurally recognizable to a human time traveler visiting from the Cretaceous period, but it would have been profoundly, subtly different in 1,000 incredibly tiny, interconnected ways. You would see entirely new species standing precisely where the old, extinct ones had once been. You would witness entirely new hunting and foraging behaviors, entirely new, complex ecological relationships, and entirely new biological forms perfectly filling entirely new ecological niches. The dinosaurs weren't physically changing because the surrounding world was violently forcing them to change. The entire globe was still incredibly warm, still densely, heavily forested, and still fundamentally, undeniably Mesozoic in its overall atmospheric character. They were constantly changing simply because that is exactly what biological life does. It relentlessly explores new possibilities. It aggressively fills every inch of available space. It continuously, endlessly diversifies. But the truly massive planet-altering changes were steadily, quietly approaching. Roughly 55 million years ago, the entire planet was about to undergo an experience that was absolutely, completely unprecedented in its recent history. A sudden, unimaginably dramatic and violent spike in global warming that would rapidly push atmospheric temperatures to extreme, blistering levels that had not been experienced in tens of millions of years. The Paleocene thermal maximum was rapidly approaching and would ruthlessly test the biological limits of the dinosaurs in ways they had never been tested before. The only question was whether or not their biology was ready to endure the fire. Around 55 million years ago, something truly extraordinary and terrifying happened to the fundamental climate of the Earth. Within a microscopic span of perhaps just 20,000 years, which is less than a blink of an eye in the vast scale of geological time, average global temperatures violently spiked by an astonishing 5 to 8 degrees Celsius. The extreme polar regions, which were already comfortably warmed by our modern human standards, suddenly became positively, suffocatingly tropical. Towering palm trees actively grew along the coast of Alaska. Massive crocodilians lazily basked on the sun-drenched shores of the Arctic Ocean. The deepest, darkest parts of the global oceans warmed by several entire degrees, an event that fundamentally, completely altered vital, life-sustaining circulation patterns and completely restructured complex marine ecosystems around the entire globe. Modern climate scientists refer to this specific, hyperheating event as the Paleocene thermal maximum, or the PTM, and it remains one of the absolute most dramatic, sudden climate shifts to have occurred in the last 100 million years of Earth's planetary history. The underlying cause of this thermal nightmare was almost certainly a sudden, massive release of locked carbon directly into the atmosphere. This may have originated from apocalyptic volcanic activity directly associated with the violent geological opening of the North Atlantic Ocean. It may have been triggered by the sudden, catastrophic destabilization of massive, frozen methane hydrates resting on the deep ocean floor. Or perhaps it was a result of some terrifying, compounding combination of both events. The ultimate result was a global greenhouse effect infinitely more intense, suffocating, and extreme than absolutely anything the dinosaurs had physically experienced since the sweltering days of the ancient Triassic period. It was the ultimate biological stress test. And in our actual historical timeline, this extreme heatwave reshaped mammalian evolution incredibly dramatically. Many early mammalian species simply could not cope with the heat and went entirely extinct. Other surviving lineages drastically, rapidly shrank in physical size, an evolutionary adaptation driven by the simple thermodynamic fact that smaller bodies are vastly easier to keep cool. Entirely new, highly specialized mammalian lineages suddenly appear in the fossil record, perfectly adapted to these new, sweltering hothouse conditions. The very first true primates, the specific, tree-dwelling lineage that would eventually, slowly give rise to monkeys, great apes, and humans, make their very first appearance in the global fossil record right around this exact thermal boundary, almost as if a severe thermal crisis had violently ripped open entirely new ecological doors, even as it slammed others permanently shut. In our theoretical alternative timeline, this exact same thermal crisis would have absolutely, undeniably occurred. The PTM was completely driven by deep, internal geological processes that had absolutely nothing whatsoever to do with the rogue asteroid impact. But in this scenario, it would have been the magnificent dinosaurs, not our tiny mammalian ancestors, who were forced into facing the fiery challenge. And here's where the science reveals a truly fascinating, unexpected twist. The massive dinosaurs might actually have been vastly, significantly better biologically equipped to safely handle extreme, sustained global heat than the mammals ever were. I want you to deeply think about the biological problem of heat from a strictly physiological perspective. All mammals are endotherms. This means they internally generate all their own body heat, and their bodies must work incredibly, tirelessly hard to constantly maintain a highly specific, constant internal core temperature, which is usually hovering right around 37 degrees Celsius. This internal furnace is incredibly, highly metabolically expensive to run, and it requires highly sophisticated, complex biological cooling mechanisms to prevent the animal from cooking itself alive. Mammals require sweating, heavy panting, constantly seeking out dark shade, and severely restricting their physical activity to only the coolest, darkest parts of the day. Whenever the ambient environmental temperatures begin to closely approach or actually exceed the animal's internal body temperature, these cooling mechanisms quickly become vastly less effective and eventually fail entirely. A mammal trapped in extreme, suffocating heat is quite literally biologically working against the unyielding laws of thermodynamics. It is desperately trying to physically dump internal heat out into a surrounding environment that is too hot to accept it. Large, massive dinosaurs biologically operated in a completely, fundamentally different manner. They were most likely what scientists term gigantotherms. Their sheer, unfathomable physical mass meant that their internal body temperature simply remained relatively, stubbornly stable regardless of whatever extreme conditions were occurring in the external environment. They function exactly like a massive, towering tank of water that requires many hours to either warm up or cool down. Because of this massive thermal inertia, they simply didn't need to biologically generate nearly as much internal metabolic heat as tiny mammals did, because they could effortlessly absorb free ambient heat from their sweltering environment during the long days, and easily retain that exact same heat completely through the colder nights. And critically, because their biology didn't actively require them to constantly maintain the incredibly high, unwavering internal temperatures that mammals absolutely require to survive, they simply weren't nearly as physically vulnerable to catastrophic, fatal overheating when the entire world suddenly got dangerously hot. The much smaller, highly active dinosaurs possessed their very own unique, evolutionary thermal advantages. The vast majority of them were completely feathered, and complex feathers are remarkably, incredibly versatile biological insulators. They can easily be fluffed out to tightly trap warm air against the skin in freezing, cold conditions. Conversely, they can be tightly slicked down and widely spread apart to allow for rapid, highly efficient heat dissipation in sweltering, hot conditions. The exact same structural adaptation that will much later eventually help these dinosaurs survive brutal, freezing polar winters might have actively, perfectly helped them effortlessly survive the blistering equatorial summers experienced during the extreme heat of the PTM. The deepest, most tropical equatorial regions during the absolute height of the Eocene hothouse might have eventually become too challenging, even for the highly resilient dinosaurs. This extreme heat might have forced massive continental migrations away from the equator and directly toward the cooler poles, perhaps even temporarily creating vast, blistering equatorial dead zones where ambient temperatures simply brutally exceeded what absolutely any large terrestrial land animal could physiologically tolerate. But the extreme northern and southern poles themselves would have suddenly become an absolute, vibrant biological paradise. They would have been incredibly warm, deeply wet, and completely covered in lush, towering forests that extended nearly all the way to the absolute Arctic and Antarctic circles. It would have been the most perfect, ideal habitat imaginable for dinosaurs of absolutely all shapes and sizes, allowing them to rapidly, aggressively expand their territories deep into polar regions that had previously been far too marginal or challenging to comfortably inhabit year-round. But the dry land was absolutely not the only arena where this dramatic, alternative evolution was violently playing itself out. Deep beneath the waves, within the global oceans, our alternative timeline would have featured something truly spectacular that our actual, documented history sadly lacks entirely. The uninterrupted, continued evolution of the great, terrifying Mesozoic marine reptiles. In our actual timeline, the magnificent mosasaurs and the bizarre plesiosaurs went entirely, permanently extinct right at the KPG boundary, tragic victims of the exact same apocalyptic environmental catastrophe that starved the terrestrial dinosaurs on land. The massive, highly profitable marine ecological niches that they tragically left entirely empty would eventually, millions of years later, be slowly filled by the early whales, which miraculously evolved from tiny, land-dwelling, hoofed mammals over the long course of the Eocene epoch. It was undeniably one of biological evolution's absolute greatest, most dramatic physical transformations. But in our theoretical alternative timeline, those magnificent marine reptiles never once went extinct. They would have already been firmly, aggressively occupying every single one of those massive ecological niches when the extreme heat of the PTM completely reshaped the global oceans. The mosasaurs of the late Cretaceous period were operating at their absolute, undisputed evolutionary peak. They were massive, terrifying, highly streamlined sea lizards, with some staggering species reaching incredible 15 meters in overall length heavily equipped with immensely powerful, bone-crushing jaws and massive, paddle-like limbs designed for explosive speed. They were the absolute, undisputed apex predators of the warm, shallow inland seas, flawlessly filling ecological roles that are incredibly similar to the roles filled by modern great white sharks and highly intelligent orcas in our oceans today. Without the violent interruption of the extinction event, they would have simply, ruthlessly continued to evolve. Some highly specific lineages might have become even more aggressively streamlined, vastly faster, and perfectly, biologically adapted to relentlessly hunting swift fish and elusive squid deep out in the vast, open ocean. Other, more robust lineages might have simply grown larger and larger still, effortlessly exploiting the massive, unprecedented abundance of marine life blooming in the sweltering Eocene hothouse. And the incredibly bizarre Pleistocene, those incredibly strange, almost alien-looking long-necked marine reptiles that had already successfully persisted for well over 135 million years before the rogue asteroid finally ended their reign, would have seamlessly continued their own highly strange evolutionary journey. Their highly unique physical body plan, featuring 4 massive, incredibly powerful flippers and an incredibly long neck that could sometimes be physically longer than the entire rest of the body of many other animals, seems almost absurdly, comically impractical to our modern mammalian eyes. Yet, the fossil record proves it works spectacularly, undeniably well enough to successfully sustain their entire lineage straight through both the Jurassic and Cretaceous periods. Perhaps, swimming in the rapidly warming, highly productive oceans of the Eocene, some specific plesiosaur lineages would become vastly more efficient, highly specialized ambush hunters. Their incredibly long serpentine necks could have evolved into highly specialized, lightning-fast ambush weapons, allowing them to suddenly strike directly at the heart of massive schools of fish from entirely unexpected, impossible angles. Perhaps entirely other lineages would have completely abandoned active hunting and instead become massive, slow-moving filter feeders, using highly modified teeth to effortlessly strain millions of tiny plankton directly from the warming, nutrient-rich waters in the exact same manner that giant baleen whales operate today. The ultimate point is that the vast, global oceans of our alternative timeline would have looked fundamentally, completely different from the oceans of our actual recorded history. Instead of seeing pods of whales, playful dolphins, and barking seals, which are all heavily modified descendants of tiny land mammals that eventually returned to the sea, we would have instead witnessed a spectacular, continued diversification of ancient reptilian lineages that had already been perfecting the art of marine life for hundreds of millions of years. The massive ecological niches available to them would have been exactly similar, but the actual biological animals filling them would have been completely, unrecognizably different. Right on the very edges of the coastlines, where the dry land violently met the swelling sea, yet another ancient group would have been absolutely thriving: the magnificent pterosaurs. In our actual historical timeline, they tragically went entirely extinct right alongside their dinosaur cousins, completely abandoning the open skies to surviving feathered birds. But in our alternative history, they would have powerfully persisted, and the incredibly warm, highly biologically productive, sweltering seas of the Eocene epoch would have been the absolute, perfect, ideal habitat for them to thrive in. I want you to vividly picture a highly derived, massive pterosaur, possessing a staggering wingspan roughly the physical size of a small, twin-engine airplane, effortlessly soaring on the warm thermal currents high over the sparkling, tropical waters. Picture it suddenly diving down and effortlessly plucking a massive, writhing fish directly from the ocean surface using a lethal, spear-like beak that is the exact length of a human arm. Now picture massive, deafeningly loud, squawking colonies of vastly smaller pterosaur species, packed tightly together and actively nesting on towering, sheer sea cliffs, perfectly filling the exact same ecological roles that millions of noisy seabirds occupy in our world today. Picture the vast, blue skies of the Eocene epoch being entirely, peacefully shared between the leathery-winged pterosaurs and the fully feathered birds. Both groups are technically highly derived dinosaurian lineages, but they are so incredibly, fundamentally different in their physical form and evolutionary history that they would have ruthlessly competed with one another for some highly specific niches, while peacefully, seamlessly dividing up others. This intense, sweltering Eocene hothouse environment lasted for millions upon millions of years. This was an absolutely massive span of time, more than long enough for relentless biological evolution to slowly, methodically produce countless, highly specialized adaptations to its specific, sweltering conditions. Somewhere right around the 50 million year mark in our alternative timeline, the massive, global dinosaur populations would have finally reached a kind of peaceful, biological equilibrium with this incredibly warm, highly stable world. They would have been spectacularly diversified across absolutely every single continent on the globe, completely, ruthlessly dominant in nearly every single terrestrial and aerial ecological niche imaginable, and peacefully sharing the vast, deep oceans with their terrifying marine reptile cousins. It might have very easily seemed to an immortal, time-traveling observer standing at that exact moment in time that this was simply, undeniably how the physical world worked. That the great dinosaurs were as absolutely permanent and unchanging a feature of the planet Earth as the towering granite mountains and the deep, rolling seas themselves. But the planetary climate simply does not ever stay comfortably constant forever. Even as the magnificent dinosaurs were actively, spectacularly flourishing in their sweltering, global hothouse Eden, the deep, invisible, unstoppable geological processes that would eventually, permanently end were already actively underway deep beneath their feet. The immense, ancient continent of India was violently, relentlessly crashing into the heavy bedrock of Asia, aggressively thrusting the towering peaks of the Himalayas high into the atmosphere. The natural, chemical weathering of these massive, newly exposed mountain ranges would soon begin to continuously scrub millions of tons of carbon dioxide directly out of sky. Far to the south, Antarctica was steadily drifting directly toward the geographic South Pole, and very soon, a brand new, freezing ocean current would permanently isolate that entire landmass from the comforting warmth of the tropical waters. The great planetary cooling was officially about to begin, and would ultimately transform the face of the Earth far more profoundly and permanently than absolutely any rogue asteroid ever could have. The sweltering, global warmth simply could not last forever. Roughly 34 million years ago, the planet Earth initiated a massive, agonizingly slow descent into much colder environmental conditions that would eventually, millions of years later, culminate in the brutal ice ages of the Pleistocene epoch. The immediate geological trigger for this massive shift was the continent of Antarctica. For many millions of years, this massive southern landmass had been physically connected to the tip of South America by a very narrow terrestrial land bridge, and incredibly warm, circulating ocean currents flowing from the tropics had been easily able to reach its shores, effectively keeping its climate relatively mild despite its extreme polar geographic position. But as the immense continental plate slowly drifted apart, ripping that land bridge to pieces, a completely new, freezing ocean current physically formed, the Antarctic Circumpolar Current. This massive flow of freezing water completely isolated Antarctica from the residual warmth of the rest of the world. For the very first time in hundreds of millions of years, massive, permanent ice sheets actively began to form and spread across the continent. The global planetary thermostat had been violently turned down, and it would absolutely never fully recover its former heat. The environmental effects of this deep freeze rippled aggressively outward from the poles. Average global atmospheric temperatures rapidly dropped by several entire degrees. Global sea level significantly fell as unimaginable millions of gallons of water became permanently locked up in the expanding Antarctic ice shelves. Global rainfall patterns violently shifted as the vital temperature gradients located between the equator and the poles aggressively steepened, and the massive, towering forests, those seemingly endless, pole-to-pole expanses of deep green that had thoroughly characterized the golden age of the dinosaurs, slowly began to retreat. This was something entirely new for an astonishing 150 million years. Stretching back long before the very first primitive dinosaur ever walked the Earth, the planet had operated strictly as a massive greenhouse world. It was uniformly warm, incredibly wet, and completely covered in dense vegetation from the high Arctic all the way to the deep Antarctic. The magnificent dinosaurs had originally evolved in this Pacific world, wildly diversified in this Pacific world, and successfully conquered absolutely every single continent in this Pacific world. They had absolutely never faced a planet where miles-thick ice sheets permanently covered highly significant portions of the dry land. A world where the winters could be genuinely, lethally harsh, and where the endless forest eventually gave way to something else entirely. The severe Oligocene cooling was the ultimate biological test, completely unlike anything they had ever experienced before in their genetic history. But right here is exactly where we must actively, aggressively challenge a highly common, modern scientific assumption. We heavily tend to mistakenly think of dinosaurs purely as tropical animals, viewing them as fragile creatures of incredibly warm climates that couldn't possibly hope to survive in freezing, snowy conditions. After all, they are almost universally depicted standing in steaming, humid jungles, utilizing their massive, scaly bodies to soak up the intense warmth of a prehistoric sun. And our modern, everyday comparison to living reptiles only seems to falsely reinforce this heavily biased impression. Modern snakes and tiny lizards simply do not do well in freezing, cold climates, which is exactly why you absolutely do not find them heavily populating the ice shelves of Antarctica. The glaring problem with this deeply ingrained assumption is that it is almost certainly definitively wrong. We now possess the hard fossil evidence to know for an absolute fact that magnificent dinosaurs lived deeply within the freezing polar regions throughout the Mesozoic era. Fossil excavation sites located deep in frozen Alaska and Antarctica have miraculously yielded thousands of dinosaur bones recovered from extreme latitudes that would have absolutely experienced months of endless, freezing winter darkness, accompanied by temperatures that regularly, deeply dropped well below the freezing point. These animals weren't simply occasional, lost visitors, or confused, wandering stragglers. They were massively established, permanent populations, actively breeding and successfully raising their young in freezing, dark conditions that we humans would consider incredibly harsh by absolutely any survival standard. The world-famous Prince Creek Formation, located in northern Alaska, flawlessly preserves a wildly diverse dinosaur ecosystem dating back to roughly 70 million years ago, prominently including giant hadrosaurs, heavily armed ceratopsians, and terrifying tyrannosaurs, all successfully living year-round well above the Arctic Circle. Exactly how did they manage to do it? The biological answer was literally actively covering their physical bodies. Feathers. We have definitively known for several decades now that a massive number of dinosaurs were entirely feathered. And this was absolutely not just isolated to the small, incredibly bird-like theropods, but stretched across a surprisingly massive, highly diverse range of separate species. Direct evidence of feathers has been miraculously found on massive tyrannosaurs, on beaked ornithischians, on dinosaurs both incredibly large and incredibly small, stemming from wildly different evolutionary lineages spanning across the entire family tree. The original, fundamental biological function of these complex feathers absolutely wasn't for powered flight. It was strictly for thermal insulation. They naturally evolved to efficiently keep these dinosaurs warm, to tightly trap internal body heat directly against the skin, and to allow these incredibly active animals to remain highly functional in freezing conditions that would have instantly sent a completely naked, cold-blooded reptile into a fatal state of torpor. In our theoretical alternative timeline, this exact biological adaptation would have proved absolutely, fundamentally crucial as the entire world slowly cooled down. The feathered theropods, which are already perfectly equipped with nature's absolute most incredibly versatile thermal insulation, would have easily been able to aggressively expand their hunting territories deep into much colder habitats as the massive ice sheets relentlessly advanced. I want you to vividly picture a highly coordinated pack of medium-sized, lethal theropods, their entire bodies heavily covered in thick, downy plumage that violently ruffles in a frigid, biting wind, actively hunting across a barren, snowy landscape that would have been completely, biologically unthinkable back in the sweltering Mesozoic. These specific creatures would have looked remarkably, undeniably bird-like, primarily because they were essentially highly derived birds that simply had never given up hunting on the ground. The massively larger dinosaurs, however, face an entirely different thermal challenge. A towering, 15-meter-long sauropod simply couldn't rely on a coat of feathers for thermal insulation in the exact same way that a 2-meter-long theropod could. The fundamental mathematics of their surface area to volume ratio simply doesn't work out in their favor. But the biological concept of gigantothermy easily cuts both ways. The exact same massive thermal inertia that effortlessly helped a large dinosaur successfully survive the sweltering Eocene heatwave would have perfectly helped them survive moderate, freezing cold. Their massive, towering bodies would have naturally changed temperature so incredibly slowly that short, brutal cold snaps simply wouldn't affect them very much. They might have actively migrated seasonally, slowly following the retreating warmth and the vital food supplies in the exact same way that many massive, large mammals do today. Or they might have simply eventually become physically restricted to the warmer equatorial regions, entirely ceding the freezing, higher latitudes to their vastly smaller, far more thermally adaptable relatives, the beaked ornithischians, the heavily armed ceratopsians, the grazing hadrosaurs, and the armored ankylosaurs, present a truly fascinating evolutionary question. We absolutely do not currently possess direct, indisputable fossil evidence that they were entirely feathered, although some highly specific, rare specimens heavily suggest they possess dense, filamentous integuments that might have easily served a very similar insulating purpose. In our alternative, cooling timeline, the intense, unrelenting selective pressures of the freezing climates might have aggressively driven the rapid evolution of vastly thicker, highly insulating body coverings within these specific lineages. Picture a massive horned ceratopsian living deep in the freezing Oligocene epoch. Its entire, bulky body is heavily covered in a dense, shaggy coat of highly insulating protofeathers. Its massive, iconic bone frill had perhaps been significantly reduced from a massive, elaborate visual displays of its ancient Cretaceous ancestors to something vastly more practical, heavily streamlined against the biting cold. It would have visually looked something incredibly similar to a Pleistocene woolly rhinoceros, but heavily possessing the unmistakable, terrifying physical silhouette of a heavily armed, horned dinosaur. But the single most profound, revolutionary change wasn't actually occurring within the dinosaurs themselves. It was occurring directly in the physical world they actively inhabited. As the global climate steadily cooled and aggressively dried out, the endless, sprawling forests slowly began to break apart. Towering trees absolutely require certain minimum atmospheric temperatures and highly specific, massive rainfall amounts to successfully thrive. And exactly as those vital environmental conditions slowly retreated directly toward the equator, the massive forests heavily retreated right along with them. In their place, something entirely, fundamentally new was slowly appearing. Vast, open landscapes, sprawling woodlands with massive, empty gaps located between the trees, wide meadows, and massive clearings where the unshielded sunlight directly reached the soil. These weren't quite yet the magnificent, endless grasslands that would much later come to completely transform the planet, but they were the definite, undeniable beginning of something revolutionary. The ancient, shadowed age of the dense forest was slowly drawing to a permanent close, and the bright, exposed age of the open spaces was just beginning to dawn. For magnificent dinosaurs that had already spent an incredible 150 million years perfectly mastering life inside the dense forests, this was a profound, terrifying environmental shift. The fundamental, unwritten biological rules of survival were violently changing. In a dark, tangled forest, you can easily hide. You can silently ambush your prey or successfully avoid massive predators simply by staying entirely out of sight. Physical size matters vastly less than absolute stealth, and top speed matters vastly less than tight maneuverability. But out in a completely open landscape, there is absolutely nowhere left to hide. You only survive by being incredibly fast enough to effortlessly escape, or incredibly big enough to violently fight back, or incredibly vigilant enough to spot approaching danger long before it is entirely too late. Herd behavior suddenly becomes a massive biological advantage because hundreds of watchful eyes are vastly better than just two. Long distance, sustained endurance running suddenly becomes vastly more biologically valuable than short, explosive sprints. These are the exact, identical evolutionary pressures that would later completely reshape mammalian evolution in our actual timeline, ultimately producing the fast-running horses, the leaping antelope, the pack-hunting wolves, and the sprinting big cats that eventually came to completely dominate the open plains ecosystems. In our theoretical, alternative timeline, the exact same, unrelenting evolutionary pressures would have actively operated on the surviving dinosaurs. And the resulting biological outcomes might have been startlingly, incredibly similar, Not because the dinosaurs would have somehow magically evolved into actual mammals, but simply because the exact same complex ecological problems strongly tend to produce incredibly similar biological solutions through convergent evolution. A highly adapted, fast-running herbivore is ultimately a fast-running herbivore, regardless of whether it's a mammalian horse or a reptilian ornithomimid. A highly coordinated pack-hunting predator is a pack-hunting predator, regardless of whether it is a mammalian wolf or a highly derived feathered theropod. The Oligocene epoch was a massive, global transition, a vital ecological bridge between the warm, dense forests of the ancient Eocene and the endless, open grasslands that were rapidly approaching. The dinosaurs that successfully emerged from it would have been fundamentally, physically different from their ancient Cretaceous ancestors, vastly better adapted to freezing cold, vastly better adapted to surviving in massive, open spaces, and rapidly beginning to fully develop the complex, specialized adaptations that the New World would absolutely demand. They had successfully survived their very first major planetary test. But the truly massive, global transformation was still to come. Roughly 23 million years ago, a highly humble, seemingly insignificant family of low-growing plants would initiate a massive biological conquest that would completely, permanently reshape absolutely every single continent on Earth, with the sole exception of frozen Antarctica. Grass was about to change absolutely everything. Grass truly doesn't seem like a highly revolutionary or dangerous organism. It is incredibly humble. It grows exceedingly low to the ground, and it is easily, constantly overlooked. You simply walk directly on it, you ruthlessly mow it down, and you largely forget it even exists. But beginning roughly 23 million years ago, directly in the early Miocene epoch, grass initiated a massive, global conquest that would permanently transform the physical face of the Earth far more thoroughly and completely than any violent asteroid impact ever could. By the time its relentless spread was finally done, grass would entirely cover roughly 40% of the planet's entire terrestrial land surface, and it would actively create entirely new, vast ecosystems that had absolutely never existed in the first 400 million years of biological life on land. To properly understand exactly why grass was so biologically revolutionary, you truly need to understand exactly what makes it fundamentally, physically different from almost all other plants. The vast majority of plants actively grow directly from their topmost tips. If you physically damage the top of a tree, you have effectively removed its vital growing point, severely stunted its overall physical development, and perhaps even kill the organism entirely. But grass biologically grows directly from its hidden base. You can ruthlessly cut it, violently burn it, or heavily graze it all the way down to a tiny stubble, and it simply, effortlessly regrows from the dirt below. This highly unique adaptation makes grass almost entirely impossible to permanently kill through heavy animal browsing or massive wildfires. It is the botanical plant equivalent of a mythological hydra. You aggressively remove its head, and it simply grows right back. Grass also naturally produces millions of tiny silica phytoliths, which are essentially microscopic, abrasive particles of biological glass deeply embedded directly within its cellular tissues. These tiny glass particles make grass incredibly tough, highly abrasive, and incredibly difficult to properly digest. Absolutely any herbivorous animal that attempts to eat grass is essentially painfully chewing on raw sandpaper, rapidly, destructively wearing down its vital teeth with every single bite. In our actual documented timeline, this brutal reality forcefully drove the rapid evolution of hypsodont teeth, the massive, high-crowned, continuously growing teeth that perfectly characterize modern horses, cattle, and other highly specialized grazing mammals. Any herbivorous animals that simply couldn't genetically evolve physical solutions to the massive grass problem simply couldn't physically exploit the massive new grassland ecosystems. They were permanently, hopelessly locked out of one of the planet's absolute greatest, most profitable ecological opportunities. The massive, global spread of the grasslands was heavily driven by the exact same steady cooling and drying trends that had successfully begun back in the Oligocene. As the vital, life-sustaining rainfall heavily decreased across the massive continental interiors, the ancient forests aggressively retreated toward much wetter areas located near the coastlines and massive river systems. The massive, open spaces completely between them rapidly filled with spreading grass, not because the grass specifically preferred those harsh, dry conditions, but simply because the highly resilient grass could easily tolerate them when the massive trees simply couldn't. Grasslands are, in a very real biological sense, the vegetative equivalent of incredibly tough, hardened survivors, aggressively colonizing the harsh, marginal lands that absolutely nothing else can physically hold on to. In our actual timeline, the massive Miocene grasslands actively triggered one of the absolute greatest, most explosive adaptive radiations in all of mammalian history. Early horses aggressively evolved from tiny, dog-sized forest dwellers into massive, large, incredibly fast-running grazers we know today. Ruminants, such as cattle, deer, and antelope, wildly, explosively diversified, heavily developing highly complex, multi-chambered stomachs that finally allowed them to efficiently extract vital nutrition from the incredibly tough plant material that most other mammals simply couldn't digest. The massive predators naturally, aggressively evolved to perfectly match them. The direct ancestors of modern wolves and big cats became vastly faster, incredibly more social, and vastly better physically adapted to actively hunting in wide open, exposed terrain. The modern African savanna, complete with massive endless herds of wildebeest and zebra, its highly coordinated prides of lions, and its vicious packs of wild dogs, is the absolute culmination of 20 million years of highly specialized evolution specifically operating within grassland ecosystems. In our theoretical alternative timeline, the massive grasslands would have spread precisely as they did in our own actual history. The shifting planetary climate patterns that actively created them had absolutely nothing whatsoever to do with exactly what types of animals happened to be present. The only fundamental difference is that it would have undeniably been the dinosaurs, absolutely not the mammals, who were actively facing the brutal challenge of biologically adapting to this terrifying new world. And the evolutionary pressures would have been perfectly identical. Eat the abrasive grass or slowly starve to death, run incredibly fast or violently die, see the predators coming from miles away, or quickly become their next meal. The resulting biological solutions, driven entirely by the highly implacable, ruthless logic of natural selection, would highly likely have been remarkably, shockingly similar. Consider the magnificent Ceratopsians, the heavily horned dinosaurs that already thoroughly dominated the large herbivore niches of late Cretaceous North America. Back in the ancient, shadowed forests, they had been highly successful browsers, effortlessly using their sharp, parrot-like beaks to precisely crop soft vegetation, and utilizing their powerful, shearing teeth to properly process it. But those specific, ancient teeth simply weren't physically designed for eating glass-filled grass. They would have worn down incredibly quickly against the heavily silicon-laden tissues, leaving the starving animals completely unable to feed efficiently. The highly specific Ceratopsians that successfully survived in a grass-dominated world would have been the exact ones that successfully evolved physical, biological solutions to this massive problem. One very strong possibility is the rapid evolution of truly ever-growing teeth, highly similar to those found in modern rodents and horses. The deep, developmental genetic pathways required for continuous tooth growth already physically existed within the dinosaurs. We clearly see incredible hints of it in the massive dental batteries of the hadrosaurs, where hundreds of teeth were constantly, endlessly being replaced from the jaw below. A highly derived ceratopsian lineage that finally evolved truly hypsodont teeth would have been perfectly able to graze on the plains indefinitely, endlessly wearing down its teeth against the tough grass, and simply growing more teeth to replace them. I want you to vividly picture a highly evolved descendant of the famous Triceratops, exactly 20 million years biologically evolved from its ancient Cretaceous ancestor. It is absolutely still structurally recognizable as a massive ceratopsian. The fundamental, core body plan simply works far too well to ever completely abandon, but the overall physical proportions have drastically changed. The massive head is now much longer, resting much lower to the ground, perfectly adapted for endless grazing rather than high-level browsing. The sharp beak is now vastly wider, much more heavily squared off, perfectly designed to efficiently crop massive swaths of tough grass like a massive, living lawnmower. The massive bone frill has significantly shrunk, as it is no longer biologically needed for elaborate display or thermal regulation in exactly the same way. That vital biological energy has been heavily invested instead into the massive, bulging jaw muscles required to efficiently process thousands of pounds of tough vegetation. It constantly moves in massive herds consisting of hundreds or thousands of individuals across the endless Miocene prairies, functioning as a massive, unstoppable river of muscle, flesh, and horn gracefully flowing across the open landscape, exactly like wildebeest migrating across the modern Serengeti. But constant, open plains grazing aggressively brings its very own terrifying dangers. In a dense forest, you can easily hide your massive body from predators. Out on an entirely open, flat plain, you are highly visible from many kilometers away. The only remaining viable biological defenses are constant vigilance, overwhelming numbers, and sheer explosive speed. The massive herding behavior of these Miocene Ceratopsians absolutely wouldn't have been an optional choice. It would have been absolutely, biologically essential for basic survival. A lone, isolated grazer standing on an open plain is simply a dead grazer. A massive, tightly packed herd of 1,000 individuals, possessing hundreds of highly watchful eyes constantly scanning the distant horizon, actually has a fighting chance. The incredible ornithomimosaurs, the fast-running, ostrich-like dinosaurs of the ancient Cretaceous, were already heavily, beautifully pre-adapted for open grassland life in many highly significant ways. They were already incredibly fast, sustained runners possessing incredibly long legs and incredibly light, hollow builds. They were highly likely omnivorous, completely able to easily exploit a massive variety of different food sources. In a dangerous world defined by open plains, they might very easily become the absolute ecological equivalents of modern antelope and gazelles. Incredibly fast, highly alert, continuously living in massive herds, and rely entirely on sheer speed to successfully escape predators. Imagine a highly evolved Miocene ornithomimid. Its muscular legs are now even longer than those of its ancient ancestors. Its feathered body is heavily streamlined for incredible, sustained running directly across flat, unyielding terrain. Its long neck is exactly tall enough to easily see directly over the tall grass to accurately spot any danger approaching from absolutely any direction. It peacefully feeds on a massive mixture of grass seeds, small insects, and tiny mammals, a highly opportunistic, varied diet that seamlessly allows it to thrive in harsh environments that are simply far too brutal for highly specialized eaters. When it is suddenly threatened, it can easily reach blistering speeds exceeding 60 kilometers per hour, which is vastly fast enough to completely outrun absolutely any massive predator that relies purely on straight pursuit. It lives its life in highly social groups of dozens, and when just one single individual spots an approaching threat and violently bolts, the others instantly follow, creating a massive, confusing wave of panic rapidly spreading to the herd vastly faster than any predator can physically react. The massive hadrosaurs present a truly fascinating, incredible evolutionary case. Their highly sophisticated, complex dental batteries, those massive rows containing many hundreds of tightly interlocking teeth, were already the absolute most incredibly efficient plant processing biological machinery any dinosaur had ever successfully evolved. In many highly significant ways, they were completely, beautifully pre-adapted for eating grass, fully capable of effortlessly handling the incredibly tough vegetation that would have utterly defeated nearly all other herbivores. Perhaps, in our theoretical alternative timeline, the heavily built hadrosaurs would have eventually become the absolute, undisputed dominant grazers of the plains. Their massive pre-existing physical adaptations would have granted them an incredible, unbeatable head start in the brutal, global competition for the new grass. But there is yet another fascinating possibility, one that seems vastly more scientifically likely given the unyielding rules of global evolutionary competition. Perhaps absolutely no single dinosaur lineage would have completely dominated the space. Perhaps the vast, endless Miocene grasslands would have been carefully, violently partitioned among multiple different, highly specialized dinosaur groups, each one flawlessly specializing in slightly different, overlapping niches, exactly just as the modern African savanna today is beautifully, brutally shared among wildebeest, zebra, Cape buffalo, gazelle, and a dozen other incredible species, each efficiently exploiting the vast grassland in its very own, highly unique way. The vast, global ecological theater had been completely rebuilt. The ancient shadowed forest stage that had hosted the entire dramatic Mesozoic era was rapidly being struck down, completely replaced by an endless, rolling plain of waving, tough grass situated under an open, massive sky. Entirely new, highly profitable biological roles were suddenly available for absolutely any evolutionary actors willing to rapidly learn the new lines. The great dinosaurs had already spent a staggering 150 million years perfectly mastering life in the forest. Now they had perhaps another 20 million years to perfectly master something entirely, fundamentally different. The ultimate, terrifying question was, exactly what would be actively hunting them? Because in a harsh world defined by extremely fast-running, highly vigilant herds, the massive apex predators would absolutely have to change, too. The famous Tyrannosaurus rex was undeniably the absolute apex predator of the late Cretaceous period. 12 meters of sheer muscle and solid bone, an estimated 6 tons of raw killing power, wielding a terrifying bite force that could literally crush the chassis of a modern car. It was biomechanically built for exactly one single thing, violently taking down incredibly large, heavily armored prey through sheer, overwhelming brute force. In the incredibly dense, shadowed forests of the Mesozoic, where silent ambush was highly possible and prey simply couldn't physically see you coming until it was entirely too late, this massive, brutal strategy worked absolutely magnificently. Rex confidently sat at the very top of its local food chain for millions of years, entirely unchallenged, completely, seemingly biologically perfect. But biological perfection is always highly relative to the surrounding environment. Violently change the environment, and that exact same perfection instantly, fatally becomes obsolescence. The vast, wide-open grasslands of the Miocene epoch would have been incredibly, deeply hostile territory for a classic, heavily built tyrannosaur. In a dense forest, a massive, 6-ton predator can easily hide its bulk behind massive trees, carefully approaching within a few meters of striking distance before its unaware prey even realizes it is there. On a totally open, flat plain, there's absolutely no hiding a massive predator that stands a full 4 meters tall at the hip. The vigilant prey animals can clearly see you coming from many kilometers away. By the exact time you get close enough to finally launch and attack, they're already running at full speed, and you, heavily burdened with your massive, bulky body and relatively short, muscular legs, absolutely cannot ever catch them. This absolutely does not mean that the entire tyrannosaur lineage would have simply gone extinct. Biological evolution absolutely does not ever give up on highly successful, dominant body plans that easily, but it does undeniably mean that they would have been fiercely forced to change, and the specific, genetic direction of that change is highly predictable, primarily because we have already seen it happen before with mammalian predators violently facing the exact same open plains pressures. The terrifying tyrannosaurs of the Miocene grasslands would have slowly, steadily become vastly leaner. The brutal rules of natural selection would have heavily favored the specific individuals that were physically faster, vastly lighter, and far more highly efficient runners. Over the course of millions of years, the incredibly stocky, heavily muscled body plan of the classic T. Rex would have stretched out and heavily thinned, evolving vastly longer legs relative to its overall body mass, adopting a much more deeply horizontal posture for far better dynamic balance at high speed, and perhaps even evolving a significantly smaller, lighter head to heavily reduce the useless dead weight carried at the absolute front of the body. The resulting highly derived creature might have looked something incredibly similar to a scaled-up, terrifying version of the vast, earlier tyrannosaurs. Creatures highly similar to Dilong or Guanlong, which were far much more lightly built than their massive, later descendants. But even a vastly slimmed-down, highly agile tyrannosaur would have faced a massive, fundamental biological problem. The absolute largest, most profitable prey animals on the plains would have been heavily armored herd animals, and actively hunting massive herd animals entirely alone is incredibly, fatally dangerous and wildly inefficient. A single, lone wolf simply cannot ever bring down a massive, healthy bison. A single, lone lion absolutely cannot take down a full-grown Cape buffalo. The prey is simply far too large, vastly too dangerous, and completely surrounded by angry companions that might aggressively fight back. The ultimate biological solution, which was successfully discovered completely independently by modern wolves, lions, and African wild dogs, is highly coordinated, cooperative hunting. working tightly together in highly organized groups to successfully isolate, completely exhaust, and violently overwhelm massive prey that absolutely no single individual could ever hope to take down alone. Here's exactly where we naturally encounter an incredibly interesting, highly debated question about ancient dinosaur behavior. We absolutely do not currently know for scientific certainty whether the massive, large theropods actively hunted in coordinated packs. There is certainly some compelling, tantalizing evidence. Massive trackways that heavily seem to show multiple large individuals moving tightly together, and massive bone beds that contain many different predators lying right alongside their apparent slaughtered prey. But it remains highly ambiguous. Some paleontologists strongly believe Tyrannosaurs were highly social, organized hunters. Others strongly think they were strictly solitary killers, perhaps only briefly coming together to aggressively scavenge massive carcasses or to violently breed. In the complete absence of absolute scientific certainty, we simply have to reason directly from core ecological principles. And those very ecological principles strongly suggest that the grassland tyrannosaurs would have almost certainly undeniably become highly organized pack hunters. Not because there's anything inherently magical about the grasslands, but simply because the massive prey they would have been hunting, incredibly large, highly dangerous, herd-dwelling dinosaurs, would have been almost physically impossible to successfully take down in absolutely any other way. The immense elective pressure to cooperate would have been intense. The specific individuals that could successfully cooperate would have eaten well. The individuals that stubbornly could would have rapidly starved to death. Over the span of millions of years, that is more than enough brutal pressure to completely reshape their fundamental behavior, to slowly build vastly larger brains capable of highly complex coordination and communication, and to successfully create entirely new social structures that simply hadn't existed before. I want you to heavily picture a highly coordinated pack of Miocene tyrannosaurs, perhaps 6 or 8 massive individuals, silently moving together across the tall grassland in the pale, early morning light. They are vastly smaller than their ancient Cretaceous ancestors, maybe roughly 7 meters long instead of towering 12, weighing perhaps 3 tons instead of a massive 6, but they are vastly faster, infinitely more agile, and actively working seamlessly together with a level of high coordination that the ancient T-Rex never biologically needed. They have successfully spotted a massive herd of grazing Ceratopsians far in the distance, and now they are quietly, strategically spreading out. Some individuals are actively circling incredibly wide to successfully cut off all potential escape routes, while the others are approaching much more directly to violently drive the panicked herd straight toward the hidden ambush. When they finally launch their attack, it is absolutely not the clumsy, overwhelming head-on assault of a single giant predator, but rather a terrifyingly coordinated strike coming from multiple different angles simultaneously. Each specific individual innately knowing its exact role, actively working together to violently bring down massive prey that absolutely none of them could ever hope to kill entirely alone. But the majestic Tyrannosaurs absolutely weren't the only terrifying theropod lineage rapidly adapting to the harsh new grasslands. The vastly smaller, highly agile predators, the vicious dromaeosaurids, the incredibly smart trinotids, and the other various maniraptor and theropods would have been rapidly evolving right alongside them, perfectly filling entirely different, vital niches in the brand new ecosystem. In many highly significant ways, these vastly smaller predators were much better biologically pre-adapted to open grassland hunting than the massive tyrannosaurs ever were. They were already incredibly fast, sustained runners. Many of them already heavily seemed to have been highly social, actively hunting in coordinated groups based firmly on the limited fossil evidence we currently possess. They already had highly dexterous, grasping hands that could easily manipulate objects, forward-facing eyes that generously provided excellent, overlapping depth perception, and relatively massive brains compared to their overall body size. The massive, open grasslands would have aggressively rewarded every single one of these physical traits. The famous dromaeosaurids, the terrifying raptor dinosaurs heavily popularized by Jurassic Park, would have been particularly, spectacularly well suited to highly organized pack hunting on the open plains. They were already highly specialized pursuit predators built strictly for explosive speed and tight agility. Their world-famous, terrifying sickle claws were highly likely utilized to heavily grip onto their prey, while their jaws violently delivered the fatal, killing bites, an aggressive, terrifying technique that works infinitely better when multiple different individuals can aggressively attack simultaneously. In our theoretical alternative timeline, the massive dromaeosaur lineages might have wildly diversified to perfectly fill ecological roles highly similar to those of modern African wild dogs and gray wolves. Highly organized pack hunters that ruthlessly run down their exhausted prey through sheer, unstoppable persistence rather than a sudden, hidden ambush. Imagine a terrifying pack of Miocene dromaeosaurids, roughly 2 meters long, their bodies completely covered in striped, heavily camouflaged feathers that perfectly break up their physical outlines directly against the tall grass. They actively hunt in massive, highly organized groups of 20 or more individuals, constantly communicating through complex, highly specific vocal calls and subtle body language, flawlessly coordinating their rapid movements across many kilometers of wide-open, completely exposed terrain. Their brutal hunting strategy is incredibly simple but terrifyingly effective. Accurately identify a weak target, relentlessly pursue it until it completely tires out, and simply take turns keeping the intense pressure on while the other pack members briefly rest. It is the exact identical strategy successfully utilized by African wild dogs today, and it is devastatingly, unbeatably effective against any prey that relies entirely on sheer speed for its basic survival. Absolutely no animal on Earth can run at its absolute maximum speed forever. Eventually, total exhaustion always wins. The bizarre Tridentids heavily represent perhaps the absolute most intriguing evolutionary possibility of them all. These specific creatures were undeniably the great intellectuals of the ancient dinosaur world. Small, incredibly lightly built, completely feathered theropods boasting the absolute largest brain-to-body size ratio of any known dinosaur in history. We will actively explore their incredible evolutionary potential in vastly more detail in the next chapter, but they would have been highly formidable, incredibly successful grassland predators in their very own right, highly likely hunting much smaller prey that the vastly larger predators simply ignored, and perhaps actively developing vastly more highly sophisticated, complex social structures than absolutely any of their reptilian relatives. The massive, rolling Miocene grasslands in our alternative timeline would have been a terrifying, endless killing ground, constantly, ruthlessly patrolled by highly evolved predators at absolutely every single scale. At the very absolute top, highly coordinated packs of heavily slimmed down, agile Tyrannosaurs. They were undeniably still the absolute largest, most lethal land predators on Earth, but fundamentally, completely transformed by 50 million years of intense adaptation to entirely new environmental conditions. Down in the absolute middle, massive, terrifying packs of relentless dromaeosaurids actively running down exhausted prey through sheer, unstoppable endurance. And firmly at the bottom, highly intelligent Tridentids and other various small, feathered theropods actively hunting absolutely everything from tiny, rodent-sized mammals to massive insect to each other. The ancient, solitary age of the massive, lone giant was permanently ending. The terrifying, solitary tyrannosaur violently killing through sheer, overwhelming individual power was rapidly giving way to something entirely, fundamentally new. Predators that successfully survived and thrived entirely through complex cooperation, deep coordination, and perhaps even the very early, rudimentary beginnings of something we might actually call true, calculated strategy. In a brutal, unforgiving world completely defined by wide-open plains and highly vigilant, massive herds, large brains were rapidly becoming just as biologically important as raw physical brawn. And that profound realization naturally raises a truly massive, fascinating question. In a brutal, unforgiving world completely defined by wide-open plains and highly vigilant, massive herds, large brains were rapidly becoming just as biologically important as raw physical brawn. And that profound realization naturally raises a truly massive, fascinating question that dedicated paleontologists have fiercely debated in academic circles for many decades. Given an enormous amount of uninterrupted time, let us hypothetically say another 50 million years of continuous evolution, could the magnificent dinosaurs have successfully evolved true, profound intelligence? Could they have eventually developed complex, calculating minds entirely capable of deeply understanding the physical world around them, of strategically planning for the distant future, and of ultimately asking existential questions about their very own biological existence? The true, scientific answer to this incredible question is vastly more complicated and deeply nuanced than you might initially, intuitively think. Back in the year 1982, a highly respected Canadian paleontologist by the name of Dale Russell formally published a truly fascinating scientific thought experiment that would rapidly become one of the absolute most famous, and simultaneously one of the most fiercely controversial pieces of speculative paleontology that had ever been formally written. Russell had been extensively, meticulously studying the fossilized remains of a remarkably small, highly agile theropod dinosaur hailing directly from the late Cretaceous period, famously known in scientific circles for possessing an unusually, exceptionally large brain cavity relative to its overall physical body size. By carefully looking at the undeniable evolutionary trend of steadily increasing brain size within the specific, highly derived lineage, Russell dared ask a beautifully simple, profound question. What exactly would have occurred if the magnificent dinosaurs simply hadn't tragically gone extinct? What specific, highly advanced forms might the direct descendants of these highly intelligent theropods have ultimately become after experiencing another full 66 million years of completely uninterrupted biological evolution? His highly controversial, theoretical answer was a dinosauroid, an entirely hypothetical, highly derived creature that permanently stood fully upright balanced on two long legs, possessed highly manipulative, dexterous hands featuring fully opposable digits, and possessed a massive, heavily rounded brain case theoretically capable of successfully housing human-level abstract intelligence. Russell even went so far as to commission a highly detailed, physical sculpture of his theoretical creature, and the final, artistic result was strikingly, almost uncomfortably humanoid in its overall appearance. It featured two highly prominent, forward-facing eyes, a perfectly vertical, upright spinal posture, and a completely hairless body plan that visually looked significantly more like a gray alien from science fiction than any actual, documented dinosaur. The underlying, profound implication of this sculpture was absolutely clear. Given a sufficient massive amount of evolutionary time, the magnificent dinosaurs might have eventually evolved an incredibly high level of intelligence completely comparable to our very own. We might have eventually faced true, intellectual competition on this planet. The highly controversial hypothesis instantly, massively captured the broader public imagination, but was almost immediately fiercely criticized and thoroughly debunked by countless other prominent scientists, and that intense academic criticism has only heavily intensified over the long decades since its initial publication. The fundamental scientific problem absolutely isn't the core idea that certain dinosaurs might have slowly become significantly more intelligent over time. That is actually highly reasonable, deeply logical biological speculation that is firmly supported by the limited fossil evidence we currently possess. The massive, glaring problem is the deeply flawed human-centric assumption that extreme, high-level intelligence inevitably, universally leads to a strictly humanoid physical body plan. Russell's core evolutionary reasoning went something vaguely like this. High-level intelligence strictly requires an incredibly large, heavy brain. A massive, heavy brain strictly requires a fully upright, vertical posture to perfectly balance its extreme weight squarely on top of the spine. An upright, vertical posture absolutely requires the front forelimbs to be entirely freed from the mundane duties of physical locomotion. Completely freed forelimbs naturally, inevitably evolve into highly manipulative, dexterous hands. Therefore, absolutely any highly intelligent creature emerging in the universe will inevitably, eventually look more or less exactly like a human being. It is an incredibly seductive, highly comforting argument to make, but from a strictly biological standpoint, it is almost certainly entirely wrong. I want you to deeply consider the absolute most highly intelligent, advanced non-human animals currently alive on the Earth today. Modern crows and tropical parrots have repeatedly, definitively demonstrated staggering cognitive abilities that easily, firmly rival those of our closest relatives, the great apes. They actively, intelligently use complex tools to retrieve food. They seamlessly solve incredibly complex multi-step puzzles. They definitively recognize themselves when placed in front of mirrors. and they strongly appear to fundamentally understand deeply complex abstract concepts exactly like cause and specific effect. Yet, physically, they look absolutely nothing whatsoever like human beings. They are fundamentally, undeniably birds, completely equipped with feathered wings, hard keratin beaks, and lightweight bodies thoroughly shaped by an incredible 150 million years of highly specific avian evolution. Their staggering, undeniably high intelligence naturally evolved entirely within the rigid, unyielding physical constraints of a very strictly non-humanoid avian body plan. And those exact physical constraints absolutely didn't ever prevent them from successfully becoming remarkably, incredibly smart. Or, alternatively, deeply consider the remarkable octopuses, which can effortlessly, rapidly solve complex physical puzzles, intelligently use discarded tools for their own protection, and strongly appear to possess something remarkably, undeniably akin to highly distinct, individual personalities. An aquatic octopus is about as incredibly far removed from a terrestrial, humanoid body plan as you can possibly get on this planet. It possesses 8 massive, highly flexible arms, absolutely no internal skeletal structure whatsoever, and a highly bizarre, incredibly distributed nervous system packed with millions of active neurons located directly inside each individual tentacle. Yet, despite this alien anatomy, they are widely considered to be among the absolute most highly intelligent invertebrates currently living on Earth. Perhaps they are even among the absolute most intelligent animals on the planet, period. The vital, unavoidable scientific lesson here is that high-level intelligence is absolutely not a predetermined, magical destination that biological evolution is somehow desperately trying to reach. It is simply an incredibly useful biological tool, exactly like razor-sharp claws, feathered wings, or highly toxic venom, that naturally evolves only when highly specific. Surrounding selective pressures strongly favor its continued existence, and it can completely, successfully evolve within physical bodies of almost any conceivable shape or anatomical structure, because true, high-level intelligence is ultimately entirely about highly efficient information processing, absolutely not about possessing opposable hands or standing vertically upright on 2 legs. So exactly what would highly intelligent, heavily evolved dinosaurs actually have looked like in our timeline? They would have almost certainly, undeniably looked exactly like dinosaurs, the highly derived trinotids existing in our alternative, theoretical timeline after experiencing an incredible 66 million years of additional, uninterrupted evolution would absolutely still have been instantly, easily recognizable as fierce theropod dinosaurs. They would have strongly, stubbornly retained a fundamental, highly successful basic body plan that had flawlessly served their ancient ancestors so incredibly well for millions of years. This means they would have maintained bipedal locomotion, a heavily horizontal spinal posture perfectly balanced by an incredibly long, stiff tail, highly grasping, clawed forelimbs, and a massive, elongated head packed completely full of razor-sharp, serrated teeth. What absolutely would have radically, profoundly changed was exactly what was physically contained inside that massive head. The ancient troodonid brain was already remarkably, exceptionally large for a dinosaur of its era. The encephalization quotient, which is a highly specific scientific measure of a creature's physical brain size measured directly relative to its overall physical body size, was significantly, measurably higher in that specific lineage than in absolutely any other globally known dinosaur species. If the brutal, relentless selective pressures that we extensively discussed in the previous chapter ruthlessly continue to strongly favor elevated cognitive ability, if highly coordinated pack hunting constantly demanded vastly better communication, if brutal grassland life constantly required vastly better spatial memory for tracking resources, if deeply complex social structures constantly required actively recognizing distinct individuals and accurately remembering past, complex relationships, then the highly specialized brain might very easily have continued to rapidly, aggressively expand. Exactly how far could it have expanded? That is completely, entirely impossible to say with absolute scientific certainty, but we can easily, logically look at exactly what biologically happened with the modern birds, which represent the exact, singular dinosaur lineage that successfully survived a massive extinction event for vital evolutionary clues. Modern crows and highly intelligent parrots possess massive brain-to-body mass ratios that are entirely, definitively comparable to those found in the great apes, and they successfully managed to evolve that incredible, staggering level of heavy encephalization in roughly the exact same 66 million years that we are currently actively imagining for our theoretical alternative raptors. It is absolutely, completely not unreasonable to scientifically suppose that a highly derived, specialized lineage starting its massive evolutionary journey, when already highly impressive, advanced brain might have eventually successfully reached highly similar, staggering cognitive levels. I want you to vividly picture a highly advanced raptor roaming the late Miocene epoch, perhaps exactly 10 million years ago in our theoretical alternative timeline. It is roughly 2 solid meters long from the tip of its sharp snout to the very tip of its stiff tail, its entire body heavily covered in dense, highly complex feathers that perfectly range in color from a dusty, muted gray on its back to a stark, bright white on its underbelly. This provides perfect, flawless camouflage for the wide, open grasslands exactly where it actively hunts its prey. Its massive eyes are incredibly large and highly forward-facing, generously providing it with absolutely excellent, highly overlapping binocular vision. Its long, highly dexterous hands still firmly retain 3 sharply clawed fingers perfectly capable of highly grasping and delicately manipulating small physical objects with incredible, terrifying precision that its ancient Cretaceous ancestors simply couldn't ever have possibly managed. And its massive, highly evolved brain, safely housed entirely within a physical skull that heavily, noticeably bulges directly at the back, is unequivocally the absolute largest, most complex brain of any single terrestrial land animal currently walking on Earth in direct proportion to its overall physical body size. This specific creature is incredibly, undeniably smart. It is absolutely not human smart. We will get to exactly why that specific limitation exists in just a moment, but it is incredibly smart in highly specific, vital ways that intensely matter for its day-to-day survival. It actively hunts its exhausted prey in highly organized, massive packs consisting of 10 to 20 distinct individuals. And the deep, complex coordination of those brutal hunts is absolutely, undeniably remarkable to witness. They execute flawless, highly planned flanking maneuvers, incredibly complex diversionary tactics, and even actively participate in what strongly, undeniably appears to be completely deliberate, highly calculated deception, with some specific individuals perfectly feigning a debilitating physical injury solely to violently lure aggressive prey directly into carefully constructed, hidden ambushes. It actively, intelligently uses extremely simple physical tools, heavily utilizing small, broken sticks to precisely probe deep, dark burrows for completely hidden, terrified prey, and utilizing heavy, solid rocks to violently crack wide open highly nutritious, hard-shell food items. It possesses an incredibly complex, highly nuanced vocal repertoire, utilizing many dozens of entirely distinct, specific calls that perfectly, instantly communicate highly vital information regarding approaching predators, exact food sources, and complex internal social status. Young, highly impressionable individuals actively learn directly from their vastly older, much wiser elders, silently watching and carefully imitating highly complex physical behaviors rather than simply, blindly relying purely on ancient, inherited genetic instinct. In incredibly many highly significant, profound ways, this magnificent, feathered creature would have perfectly, flawlessly occupied a vital ecological niche strikingly, incredibly similar to that held by modern, pack-hunting wolves or perhaps even very early, primitive hominids. It is a highly social, deadly predator whose ultimate survival success firmly depends significantly more on massive, calculating brains and on raw physical brawn, vastly more on deeply complex, strategic cooperation than on sheer, unyielding individual strength. It would have undeniably been a highly formidable, incredibly adaptable predator, fully capable of successfully thriving in massive, heavily varied environments scattered completely across the entire globe. But it absolutely, definitely would not have ever built sprawling, concrete cities. It absolutely would not have ever successfully developed complex written language, advanced mathematics, or deep, abstract philosophy. It absolutely would not have ever gazed up and actively asked profound questions about the distant, burning stars, or deeply wondered about its exact, tiny place in the vast, seemingly infinite universe. Why exactly not? Because human-level abstract intelligence absolutely isn't simply just about passively possessing an incredibly big, massive brain. It is entirely about a highly, incredibly specific, unthinkably rare set of complex environmental circumstances that, as far as we can scientifically tell, have only successfully occurred exactly one single time in the entire, vast history of biological life on Earth. True, human-level, highly abstract intelligence originally exclusively evolved within the primates, a highly specific, unique biological lineage that had already successfully spent many tens of millions of years heavily developing deeply complex, intricate social structures. They already possessed highly manipulative, grasping hands originally perfectly adapted for tightly gripping swaying branches, and massive, highly active brains originally perfectly adapted for safely navigating highly complex, three-dimensional arboreal environments. Then our ancient, distant ancestors were violently, aggressively forced completely out of safe, dense trees and directly down onto the harsh, completely exposed African savanna, where they suddenly faced entirely new, utterly brutal selective pressures. The desperate, constant need to reliably find high-quality food in a deeply challenging, open environment. The absolute, unyielding need to seamlessly, perfectly cooperate in large, highly organized social groups simply to avoid being eaten. The desperate need to flawlessly, instantly communicate incredibly complex, abstract information regarding distant resources and immediate, terrifying dangers. Our ancient brains aggressively, massively expanded at a truly unprecedented rate over just a few short million years, entirely, relentlessly driven by a highly specific, intense biological feedback loop constantly operating directly between increasing social complexity and expanding cognitive ability. This exact, highly specific, miraculous sequence of evolutionary events was entirely, wholly contingent on countless, completely unrelated, random factors. Each and every single one of these factors was absolutely biologically necessary, but entirely, completely insufficient on its very own. Early primates successfully, luckily reached the massive continent of Africa, but the three completely separate times that closely related lineages successfully reached the continent of North America, absolutely none of those isolated lineages ever managed to aggressively evolve massively large, complex brains. Massive, wide-open grasslands aggressively, completely appear on absolutely every single continent on the globe, but only directly in Africa did those exact grasslands ever successfully manage to ultimately produce a highly derived, unique species entirely capable of forming true, complex, abstract thought. Basic, functional intelligence of some specific kind might actually be incredibly, remarkably calm and heavily scattered throughout the vast, cold universe, but highly advanced, abstract intelligence exactly like ours, completely capable of aggressively inventing advanced technology, pursuing rigorous science, and deeply debating philosophy, might be incredibly, vanishingly, unimaginably rare. Our theoretical, alternative Trinitids would have undeniably been incredibly, profoundly intelligent, perhaps fully, entirely as deeply intelligent as modern, problem-solving crows, social dolphins, or highly adaptable chimpanzees. They absolutely might have actively used simple physical tools, formed highly complex, hierarchical societies, and actively, successfully passed deep, vital survival knowledge directly down from one generation to the very next. But the vital, unprecedented, incredibly rare evolutionary spark that ultimately successfully lifted our ancient, distant ancestors completely away from being just a highly clever, highly capable ape and fully transformed them into a deeply wondering, highly self-aware human being. That specific, unimaginable spark might absolutely never have successfully occurred within a dinosaur lineage. Absolutely, no matter how many millions upon millions of uninterrupted years it had to violently, endlessly evolve. The magnificent dinosaurs could very easily have successfully produced highly complex creatures that deeply thought about their immediate physical world, but they absolutely would not have produced creatures that ever paused to wonder exactly why they thought. And yet, there is undeniably something deeply, almost incredibly comforting to be found directly in that specific biological limitation, because it inherently means that in our vast, theoretical alternative timeline, the entire planet Earth would have permanently, beautifully remained entirely wild, incredibly beautiful, deeply, unimaginably brutal, and utterly, totally indifferent to the incredibly human concept of absolute meaning. It would be a sprawling, massive planet composed entirely of highly adapted animals, simply doing exactly what highly adapted animals naturally do, without absolutely anyone being there to actively call it magnificent, to loudly call it terrible, or to ever vainly ask whether any of it actually had any true underlying point at all. The magnificent dinosaurs would have successfully, completely ruled the Earth for an astonishing 230 million years, entirely unchallenged, completely unbroken, and absolutely unmarked by any singular species highly capable of actively recording their very own biological existence. In that vast, sprawling, magnificent alternative world, there would absolutely be no one present to deeply miss us, simply because there would naturally be absolutely no one present to ever even know that we might have actually been. If you are fascinated by the hidden histories of our planet and the infinite possibilities of what could have been, make sure to leave a like and subscribe to Earth's documentary. Hit the bell icon to join us on our next deep dive into the untold stories of our world. And let us know in the comments below, what do you think the dinosaurs would have evolved into if that asteroid had missed?